For as long as humans have been staring up into space, we've been absolutely mesmerized by the stars. Have you ever tried to count them? It's thought at best, in the ideal location, the naked human eye will be able to see no more than 5,000 stars. That's hardly any, considering there are 170 billion galaxies in the observable universe, and in each one of them, there might be 1 to 100 trillion stars. Observable stars number about a septillion, but that's what we can observe using equipment. Even the Milky Way, the galaxy that contains our solar system, has about 400 billion stars. It's mind-boggling what could be out there. Today we are going to look at some of the mysteries of space in this episode of the infographic show, Mysterious Objects in Space We Can't Explain Yet. Don't forget to subscribe and click the bell button so that you can be part of our notification squad. Going back to the time we really didn't know much about space, ancient people could of course see the stars and also the planets Mercury, Venus, Mars, Jupiter, and Saturn. Then it all changed in 1608 when a Dutch man named Hans Lippershey patented the telescope, our window to outer space. Hot on his heels was Italian Galileo Galilei, who made his own telescope. He spotted mountains on the moon, a stream of white lights now called the Milky Way, some of Jupiter's moons, and those rocky rings that encircle the wonderful planet of Saturn. This was a high time for astronomy, and we have of course come much further. But what have we found that we just can't fathom? Perhaps the space mysteries that make us the most curious are the ones that compel us to think aliens did it. One such mystery is what looks like a perfect hexagon embossed on the planet Saturn. Found in 2006 by astronomers, this hexagon sitting right on Saturn's North Pole had people thinking it might have been left there by an intelligent alien species. Sticking with Saturn, did you know that we still can't figure out how those rings formed or why they maintain that seemingly perfect shape? They are made of ice and also rocks, that we know, and we think they formed right at the beginning of the solar system about 4.4 billion years ago. Are they made of bits of destroyed moons? Are they much younger than that? We just don't rightly know. Shooting stars, as you know, are not actually shooting stars but meteors that come into our atmosphere. But there is such a thing as a shooting star, and they are brilliant. Known as hypervelocity stars, these things rocket through space at millions of miles per hour. They could have a mass similar to our sun and are sent wandering around the cosmos at 2 million miles per hour after interacting with a supermassive black hole. According to NASA, this is what happens. A galaxy devours one star in a binary system and ejects its twin, flinging it through space at super fast speeds. We know a fair bit about them, but we are still speculating. We have stars that get kicked out, and we also have planets that get the boot. These are known as rogue planets. One such planet is CFB DSIR 2149. This planet didn't gel with its solar system and so was ejected into space where it wanders alone for, well, we don't know for how long. Astronomers tell us there are probably billions of these rogue planets looking for a home in the universe. Being a lonely planet without a home is probably better than being eaten alive. There is a term for when galaxies eat each other, and this is not surprisingly called galactic cannibalism. Two galaxies collide and one eats the other. Does this mean our closest galaxy, Andromeda, could devour us? No, because it's too far away at 2.5 million light years. That said, some experts believe the Milky Way and Andromeda will collide in about 4 billion years. We don't have to worry for now, but that's not the case for other galaxies that encroach on each other's space, literally. The galaxy with the strongest gravitational pull will always win the battle. Speaking of being devoured, or in this case, sucked away, we have something scientists call dark flow, which lies just outside the observable universe. The observable universe is said to have a diameter of 93 billion light years, and beyond that lies the dark flow. Scientists don't know exactly what it is, but it might have formed around the time of the Big Bang. This flow is pulling things into it. It is quite complicated, but one astronomer simply said, there is a structure beyond the horizon of our universe, and that structure is exerting a force on our universe. Enough of all this eating and beating, what about all the pretty things in space? Well, how does giant diamond star sound? According to space.com, that is exactly what it is, a diamond the size of planet Earth. It's the coldest white dwarf ever found, and so cold, for a star that is, that all the carbon crystallized and formed what for all intents and purposes is a diamond, a very expensive one. If a diamond star isn't a wonderful thing to behold, what about a planet that is made of extremely hot ice? You might ask, how can you have hot ice? Ice is cold, right? Astronomers call this Neptune-sized world the hot ice planet. It hangs out about 30 light years from our planet and is also less poetically called GJ436b. It orbits a sun that is much less bright and much smaller than ours, and is also very close to that sun. That's called Gliese 436. Because it's so close, it is obviously really hot on that planet, about 980 degrees Fahrenheit. but because of its strange gas makeup, it has a really bizarre form of what is called water ice, or Ice X, as astronomers call it. No one is sure what this gas makeup is, but it's weird, say scientists. This hot ice covers the planet, and it is so hot it would melt right through you. Now let's come closer to home. What are the strangest things that have ever gotten close to Earth? Well, someone once said there were blueberries on Mars, but they turned out to be rocks. They just looked really cool. And if we are going to be cute, what about the Mickey Mouse impression on Mercury? Are aliens making fun of us? Nope, the shape is merely a coincidence, just as when Jesus Christ turns up on American toast. Possibly the strangest recorded object ever to get near Earth is the one all the news media is talking about now. This is an interstellar asteroid that has sailed into our solar system, and it looks like an alien spaceship. The strange object has been wandering around space for hundreds of millions of years, and now it's waving at us. NASA was over the moon about this, stating, "For decades we've theorized that such interstellar objects are out there, and now, for the first time, we have direct evidence they exist." It's called Oumuamua, and it travels at about 59,030 miles per hour. It's thought that it came from the star Vega, which is about 25 light years away. The 400-meter diameter object is dark and red and smooth, consisting of metals, water, and ice. It's so special because this is the first time we've ever had a visitor from another part of the galaxy, on record anyway. It's still a mystery as we don't really know where it's been and how it got to us.
Just outside the front window of the spacecraft, suspended in the black, hung the jewel-like blue-green marble of the Earth. The view was beautiful, amazing, awe-inspiring. But Mission Commander Neil Armstrong didn't have the time to enjoy the view. He was sharply focused on landing the Apollo 11 lunar module, the Eagle, on the moon. There were no second chances. They'd either land, crash, or abort the lunar landing. The Eagle was only 30,000 feet and rapidly descending toward the surface of the moon when suddenly a master alarm rang and the onboard navigational computer flashed error code 1202. On July 16, 1969, Apollo 11 launched from Cape Kennedy, Florida, carrying 3 astronauts: Commander Neil Armstrong, Commander Module Pilot Michael Collins, and Lunar Module Pilot Edwin Buzz Aldrin on a mission to the moon. Once Apollo 11 reached the moon and entered lunar orbit, the lunar module, named the Eagle, undocked from the command and service modules, which formed the Columbia. The spacecraft then made a carefully controlled descent to land on the moon. After the Eagle touched down at 2017 UTC on July 20, 1969, 650 million people worldwide watched their TVs in awe as Commander Armstrong took humanity's first step on the moon. The moon landing has become the stuff of legend, immortalized in photographs and movies. To many, it seemed like the trip to the moon was an amazing success, carried out by brave astronauts with ease. However, behind the scenes, Mission Control in Houston and the astronaut crew had to troubleshoot various hazards in real time throughout the historic mission. Here are 7 different ways the astronauts of the Apollo 11 mission almost didn't make it home. Number 1. Imagine being crammed into a tiny spacecraft with only 160 cubic feet of livable space, 7.5 minutes from the surface of the moon, and your navigational computer throws up an unknown error code. That's exactly what happened. Armstrong was preparing to land the Eagle on the moon when the Apollo guidance computer, the AGC, suddenly displayed error code 1202. The AGC was a technological marvel for its time. It was fairly compact, weighing only 70.1 pounds and requiring 70 watts at 28 volts DC. The computer was central to the mission, especially landing. Among other tasks, it managed navigation, velocity, altitude, and engine performance data. It also constantly adjusted the abort trajectory, prepared to shoot the crew back into orbit should something force an abort. Neither Armstrong nor his co-astronaut Aldrin knew what error code 1202 was. He had never even seen it during the many simulated moon landings he had done during training. Armstrong alerted Houston and they told him to ignore the error code and proceed with the mission. The computer system ended up triggering error code 1202 a nerve-wracking 4 times and 1201 once. As it turns out, the computer was being overloaded with too many commands from a radar system and was running out of memory. Number 2. Around the same time that the navigational computer was flashing overload error codes, the astronauts had another serious problem on their hands. About 9 minutes before the Eagle was set to touch down on the surface of the moon, Armstrong realized that they were going to overshoot their carefully chosen landing site. He estimated they'd miss by approximately 3 miles, which was a good guess. They actually missed it by 4. When the Eagle undocked from the Columbia, unvented residual pressure inside the tunnel that connected the 2 spacecrafts gave the Eagle an additional boost as it separated. Though slight, the extra push put the Eagle out of range of the desired landing site. The moon is covered with craters and rocks, and the planned landing site was relatively smooth. Worse yet, the lunar module was burning fuel quicker than expected. Soon, Houston alerted the Eagle that they only had 60 seconds of fuel left before they'd have to abort the mission. The spacecraft careened, skimming over the lunar terrain at 34 miles per hour. The descent engine kicked up dust from the surface, making it hard to see. With less than 30 seconds of fuel left in the tank, Armstrong landed the Eagle into a fairly smooth-looking area. The blue contact light on the console came on. Then Armstrong said the phrase that's now been committed to history: "Houston, Tranquility Base here, the Eagle has landed." Number 3. Not long after the Eagle landed on the moon, another problem began to develop. Though the landing engine fuel line had been shut down, sensors were detecting a pressure buildup. This meant that ice had plugged the descent fuel helium heat exchanger, and there was some fuel vapor caught in the line between the exchanger and the valves. The vapor was being heated by the Eagle's hot engine, building pressure which could cause an explosion. NASA rapidly drew up plans to vent the system. However, before Houston could relay instructions to Armstrong and Aldrin, the ice plug thawed and the gas dispersed on its own, remedying the problem. Number 4. Another hazard that could have prevented the astronauts from successfully completing their mission to the moon and returning home was simply an unknown. NASA didn't know how stable the surface of the moon was. The Eagle being able to land firmly on Tranquility Bay was a good sign. However, did a thin layer of moon dust cover jagged shards of rock that could cause an injury to the lander or astronauts? Although the Surveyor landers and other previous robotic missions had studied the lunar surface, it wasn't until Armstrong's iconic footstep onto the gray moon dust that NASA was sure the surface would support EVA, or extravehicular activity. As it turns out, lunar dust is dangerous, mainly due to its abrasiveness. Lunar dust has been created over billions of years by meteorite impacts. However, the moon lacks processes that would grind down these tiny particles into smoother shapes. Astronauts from various missions report tiny shards of rock permeating lunar module interiors, jamming zippers, and even penetrating layers of protective spacesuit material. Lunar dust travels ballistically because there's no atmosphere on the moon, and it will stick to anything. Number 5. A broken switch almost trapped the astronauts on the moon. No one knows exactly how the switch broke, but Aldrin is fairly certain that it happened after he and Armstrong re-entered the Eagle following their 2.5-hour walk on the moon. The flight plan instructed the astronauts to seal the lunar module's hatch, repressurize the cabin, disconnect their backpacks, and connect their spacesuit hoses to the spacecraft's life support systems. After that, they would vent the cabin once more, open up the hatch, and throw the backpacks and other unneeded equipment onto the moon's surface, thereby reducing the weight of the craft for liftoff. Though Armstrong and Aldrin had practiced the routine many times during training, somehow, during execution, one of them banged something or stumbled against Aldrin's side of the instrument panel, snapping off a small switch. Settling on the floor to rest, Aldrin happened to notice a little black switch lying in the lunar dust which had permeated the cabin. To their dismay, the astronauts realized that the broken piece was a small circuit breaker arm that controlled the power running to the ascent engine. If it was broken off, it couldn't be pressed in on the console to complete the circuit. The ascent engine wouldn't be able to power up, and the Eagle couldn't blast off the moon. The astronauts alerted Houston to the problem. While the astronauts tried to nap, NASA engineers scrambled to find a workaround that would reroute power to the engine without the switch. Unfortunately, after several hours, they still hadn't found a solution. The broken end of the switch was still visible deep inside its small hole on the console. Sadly, it was too small of a hole for a finger. However, Aldrin was able to use a felt-tipped pen to depress the circuit breaker and close the circuit, allowing the ascent engine to power back up. Basically, Aldrin pulled a MacGyver move to help get the Eagle back into the Columbia. Number 6. The command module carrying the astronauts back to Earth was almost hit by burning, disintegrating chunks of the surface module during re-entry to the Earth's atmosphere. To return to Earth, the flight plan was that the Columbia would separate into 2 parts. The astronauts would stay inside the command module, while the service module was jettisoned. Once safely away, the command module would position itself so the heat shield was facing towards Earth's atmosphere. As the command module descended to the lower atmosphere, the parachute would deploy, slowing the spacecraft and leading to a splashdown in the Pacific Ocean approximately 5 minutes later. Meanwhile, the service module would break apart and burn up while entering Earth's atmosphere. To prevent any debris from the service module accidentally colliding with the command module and injuring or even killing the astronauts, the service module was supposed to perform a series of thrust maneuvers to move it away from the re-entry path of the command module. In fact, by shifting the service module to a significantly different trajectory, its orbit would change and it wouldn't even re-enter the Earth's atmosphere at the same time as the command module. However, the thrust maneuvers of the service module failed, and both modules from the Apollo 11 mission followed the same re-entry trajectory. Luckily, no debris from the disintegrating service module hit the command module, and the astronauts were able to splash down safely. Later, it was realized that there was an error in how the service module was configured to jettison its remaining fuel. Number 7. A final issue that may have prevented the astronauts returning home was the possibility of alien infections. In 1969, only a few robotic landers had been to the moon. Their studies confirmed that the moon's surface was rocky, dusty, covered in craters, and devoid of complex life forms. However, NASA still took precautions in case the astronauts were possibly exposed to and infected by alien microbes. After the command module successfully splashed down in the Pacific Ocean on July 24, 1969, the USS Hornet recovered astronauts Neil Armstrong, Michael Collins, and Buzz Aldrin. They were immediately placed in a mobile quarantine facility and transported to the NASA Lunar Receiving Laboratory at the Johnson Space Center. There, the astronauts were moved to a larger quarantine facility. After determining that the astronauts hadn't been infected by any nasty space germs, they were released on August 10, 1969, just shy of 3 weeks after they had returned to Earth. In 1996, some 30 years after the Apollo 11 mission, a draft of the speech President Richard Nixon would have given to the nation in the event of a mission failure was released. Considering all the issues that went wrong and all the issues that could have gone wrong during Apollo 11, it's amazing that the mission was successful and the astronauts made it home. To quote the beautiful yet poignant speech that President Nixon never had to give, "In ancient days, men looked at the stars and saw their heroes in the constellations. In modern times, we do much the same, but our heroes are epic men of flesh and blood. Others will follow and surely find their way home. Man's search will not be denied. But these men were first, and they will remain the foremost in our hearts." Here at the Infographics Show, we'd like to investigate life-altering enigmas and crucial issues, such as how you could defeat Jason Voorhees, or the best life hacks for surviving a zombie attack. Yet, while our teams of world-class researchers, historians, philosophers, and undead experts are busy finding new and exciting matters to look into, what we really love is answering questions directly from you, our viewers. Today, we're going to be answering a question by Wayne, who emailed us asking, what would happen if an asteroid was hurtling toward Earth and we exploded a nuclear device in space to stop it? Well, we're going to tell you. Join us as we dive into the world of astrophysics, nuclear technology, and simple mechanics to find out what would happen if we detonated a nuke in space. Let's set the scene. A giant asteroid is speeding toward the Earth. Humanity seems doomed. And since world governments in this scenario are following the direction of Michael Bay, the solution they have come up with to stop a speeding asteroid is detonating a nuclear device in space. As the brave and surprisingly attractive men and women on this mission tearfully start their nuclear bomb planting and detonation journey, they leave the Earth's atmosphere and enter the vacuum of space, where they encounter the enemy asteroid and push the button to blast it into smithereens with their nuke. First of all, what would this blast even look like? Most of us are familiar with the mushroom cloud look of a nuclear blast, but in space this would look entirely different. When a nuclear bomb goes off, it releases a massive amount of radiation. When this radiation comes into contact with air on Earth, it rapidly expands the air, causing the classic blast wave that destroys everything around a nuke. In space with no air around, there would be no blast wave, just a spherical-looking, rapid, soundless explosion of light, heat, and radiation in every direction. The nuclear bomb's radiation in the form of gamma rays and X-rays would affect a much larger radius in space than on Earth, as there's no atmosphere to slow down or disrupt its spread. The good news is there are much fewer humans in space than on Earth that will experience this radiation. The bad news is the radiation would also make its way down to Earth's atmosphere in no time. Side effects of the blast would be seen on the planet almost immediately. Charged particles from the nuclear bomb would interact with Earth's magnetic field, creating ribbons of light that would stick around for hours or even days depending on the blast size. Imagine seeing the northern lights, but less Instagram friendly and more expansive and terrifying. In addition, debris from the blast of the asteroid would rain down into the atmosphere, though most fragments from the bomb itself would burn up and just leave heavy ions behind in the planet's atmosphere. The fragments from the asteroid, depending on its size, are a different story we'll address soon. As a side effect of a nuclear blast in space, most power sources and electronics on Earth under the blast area would be shut off, and there would be disruptions in navigation systems. High-speed, highly charged electrons from the detonation would create a dense but powerful magnetic field known as an electromagnetic pulse, or EMP for short. The EMP would disrupt the flow of electricity for hundreds of miles around the blast. How do we know this for sure? Well, because the US already detonated a nuke in space. That's right, during the Cold War arms race, the US was worried that the Soviets would launch nuclear bombs into space to stop US intercontinental ballistic missiles. Naturally, then the US set up Project Fishbowl, so they themselves could test the effects of nuclear explosions in space. One fine morning on July 9, 1962, the US mounted a W-49 thermonuclear warhead on a Thor rocket to conduct a test known as Starfish Prime. It was launched from Johnston Island, 900 miles southwest of Hawaii, past the upper atmosphere. At 9 a.m. GMT time, 11 p.m. in Hawaii, when the missile was on its way back down and had reached 240 miles above sea level, the US detonated the nuke. The explosion released 1.4 megatons of energy. That means that the blast unleashed the energy equivalent of 1.4 million tons of TNT. Because it took place in space, this massive energy burst was strangely soundless. It caused a spherical blast that created an aurora for over 1,000 miles in almost every direction. The effects of the exploding nuke were much larger and emerged much further away than US scientists had ever anticipated. The electromagnetic impulse generated by the blast changed the flow of electricity in Hawaii, 900 miles away, roughly the distance from New York City to Orlando, Florida, while people in Hawaii were getting ready to sleep and suddenly wondered why the northern lights had moved several dozen degrees lower in latitude. They were quickly distracted by blown-out streetlights, radio and telephone outages, and a whole host of other electronic malfunctions. The nuclear bomb's detonation, done close to the altitude of the International Space Station, which orbits at 254 miles above sea level, caused extensive satellite damage as well. The high-speed, high-powered electrons moving through the atmosphere hit at least 6 satellites, causing malfunctions that eventually made them fail. This was in 1962, when Earth had much fewer satellites in orbit. Today, a nuclear blast in space would probably hit hundreds of satellites. As of 2018, there are 4,987 satellites orbiting the Earth, and 1,957 of them are operational. This means a nuclear blast in space would not only send a huge surge of light and radiation charging through the Earth's atmosphere, but also disrupt your SiriusXM Deep Tracks radio station. All things considered, messed up radio stations and a weird hours-long light show would be worth it to save the Earth from a major Homo sapiens-destroying catastrophe, right? Well, it's not that simple. Depending on where the nuclear bomb had to be detonated, for example, if the location happens to be right over a country, the resulting damage could disable a whole country, if not several in one blow, by disrupting communications and electronic functions. If satellites are hit, this disruption could go on for an extremely long time. But wait, would a nuclear bomb even break apart an asteroid? And more importantly, would breaking it apart even save the Earth in the first place? Most known asteroids in our solar system are found in the asteroid belt, where they orbit the Sun between the orbits of Mars and Jupiter. Scientists believe that the asteroids are the remains of planetesimals, which were early pieces of the solar system. Some asteroids are primitive, unchanged pieces of the original solar system that never formed into larger bodies, while others are the remains of differentiated pieces of the solar system, smashed to bits by Jupiter's strong gravity. While many asteroids mind their own business orbiting within the asteroid belt, some are affected by outside gravitational pulls and flung out, setting into different orbits around the solar system. If an asteroid is big enough to pose a threat to at least part of humanity, then it must be at least 1,312 feet in diameter. 6.2 miles in diameter is the threshold for extinction-class asteroids, which pose a much larger existential threat. Extinction-class is a nice scientific way of saying everything on Earth would be dead if an asteroid that big collided with our planet, except maybe cockroaches and Keith Richards. The asteroid that caused the Chicxulub impact and wiped out 3/4 of plant and animal life on the planet 66 million years ago, including the dinosaurs, was at least 6 miles in diameter, with some scientists theorizing that it was up to 50.3 miles long. The bad news is plenty of asteroids in this extinction class still exist, rocketing all around space. The largest known asteroid, Ceres, is a whopping 294 miles in diameter, or almost 48 times larger than the size needed to end us. The good news is, sizable asteroids rarely collide with the Earth. Only once every 160,000 years, according to NASA scientists. Also, according to NASA, detonating a nuclear bomb planted at or beneath the surface of a large asteroid, even an asteroid at the bare minimum threshold of 1,312 feet, would just cause the asteroid to break apart into still large pieces rather than obliterate it. These asteroid chunks might continue racing toward the Earth and still be big enough to cause significant damage. NASA believes it would be very difficult, if not outright impossible, to determine the way in which a nuke would break an asteroid apart, so there's little hope of controlling the size of the fractured pieces. Factors like size, center of gravity, and material — some asteroids contain carbon, while others are made of iron or stony iron — would affect the way an asteroid would fracture in most unpredictable ways. However, a nuclear device still could be used to guide asteroids away from the Earth through deflection. In fact, NASA scientists think this would be the best way to use nuclear bombs to avoid colossal damage to humanity and the planet by rogue asteroids. While surface and subsurface explosions would probably just split the asteroid, nuclear bombs that explode near but not on the asteroid, in a process called standoff explosions, would hopefully release enough energy to change the asteroid's course. Thus, the recommended strategy for winning people versus asteroid is a series of standoff nuclear explosions to push the asteroid another way. We might end up with a shattered moon, but that's a risk we'll take. Is there any real chance we'll have to use this strategy soon? Well, scientists think it's unlikely, as the probability of a large asteroid hitting our Earth in the near future is slim. However, the Apophis asteroid, even though it's relatively small at 1,100 feet, is worrying a few governments. It's projected to pass within 19,000 miles of Earth's surface on April 13, 2029. Even though this seems like a massive distance, it's relatively close in space terms. If you make the comparison, the Moon is 238,900 miles away from the Earth. The fact that Apophis is swinging by the Earth on Friday the 13th probably doesn't help ease people's fears. However, most scientists are looking at this event as a data-gathering bonanza, as objects that large rarely make their way toward Earth. Still, the director of the Russian Federal Space Agency, Anatoly Perminov, announced in 2009 that Russia will brainstorm ways of deflecting Apophis if it should come too close. Of course, Apophis isn't the only sizable asteroid making its way around the universe, which is why NASA's Planetary Defense Coordination Office exists. It may sound like a division of Star Trek, but the PDCO is a real agency that uses technology like telescopes and radar to map out the orbits of existing asteroids and detect new ones. Asteroids' movements are compared to known constants like background stars in order to estimate the speed and direction of their orbit. Radar is then used to obtain information about their size and shape of the asteroid. So if the PDO detects an incoming asteroid emergency, would detonating nuclear weapons to stop them still be on the table? Sorry to disappoint fans of explosions, but that's unlikely. If it helps, the existing options sound even more interesting. Lindley Johnson of the PDCO assures us that technology such as kinetic impactors and gravity tractors would be used to divert the asteroid. A kinetic impactor is a special high-speed spacecraft that collides into an asteroid to push it onto another path, while a gravity tractor is a spacecraft that flies alongside an asteroid using its own gravity to pull the asteroid in another direction. Mars, a cold, lifeless place, yet just a few meters beneath the surface, a secret underground base hums with activity. American astronauts walk the hallways of this secret base, talking and exchanging research notes with aliens from another planet. This might sound like the opening to a fantasy novel, but according to one of the most credible individuals in the world, it's our present-day reality. Dr. Haim Eshed is not a backwoods country bumpkin talking about strange lights in the sky and little green men putting probes where the sun doesn't shine. He's one of the most respected men in Israel and America both. A former general in the Israeli military, he's also the co-founder of Israel's space agency and considered a national hero for his efforts to launch Israel into the space age. More on that, he's a professor of aeronautics and astronautics and a member of the American Institute of Aeronautics and Astronautics. As far as credentials go, short of being president, he can't get any better. And he has one message for the world. Revealed in a shocking interview in early December 2020, aliens are real and the American and Israeli governments are cooperating with them. According to Dr. Eshed, aliens representing a galactic federation of like-minded species have made contact with at least two governments on Earth, the Israeli and American governments. At this time, it's unknown if other governments are involved and that it's likely Israel's involvement is due to American cooperation, which would mean the other close US allies such as Britain and France are also likely aware of the existence of these extraterrestrials. Don't worry, these aliens aren't here to eat your brains. Instead, they're curious about humanity and awaiting a time when humanity is mature enough to join their galactic federation of allied species who share the ultimate goal of understanding the universe. Well, admittedly, that's exactly what brain-eating space aliens would want you to believe. But according to Dr. Richest, their intentions are so far peaceful. In fact, cooperation agreements have already been signed between the US and these aliens, resulting in a research laboratory on Mars itself where American astronauts work side by side with extraterrestrials. Current President Donald Trump, as of this writing, not only knows about the existence of these aliens, he nearly revealed their existence publicly but was warned not to due to concerns over mass hysteria. Surprisingly, if Dr. Richest's claims are true, it's the one piece of advice Donald Trump seems to have listened to. So, wait, is this for real? Let's explore the reasons why this claim is likely a fabrication and why it might actually be real. As you'll soon see, Dr. Richest is far from the only high-level, credible individual to have come out making a startlingly similar claim. First, let's investigate why this claim is likely false. Dr. Richest is certainly a credible witness as far as qualifications go, yet he is currently selling a book dedicated at least in part to his claims of extraterrestrial contact. That can't help but cast aspirations on his claim of space aliens. As the old saying goes, it can be hard to trust a man with a book to sell. In both the United States and Israel, though, there's another saying amongst the intelligence communities responsible for both protecting each nation's highest national secrets and discovering those of the enemies. And that saying is that aliens make great cover stories. A US CIA agent once famously said, "I love UFO stories because as long as people look up into the sky and see something weird and they're thinking alien spacecraft, they're not thinking secret US plane." This idea is pretty sound, and the fact is that it now has been proven that many UFO sightings over the years have in fact been sightings of aircrafts such as the American F-117 stealth fighter, the B-2 stealth bomber, and specially modified Black Hawk helicopters used by Special Operations Forces, especially true when those aircraft are still in their secret design and testing phases and not quite yet public knowledge. The simple truth is that aliens make for a great cover story for secret government programs, and that leads us back to Dr. Richest. Dr. Richest has a career in Israeli military, attaining the rank of general. He also helped found the Israeli space program, a vital element of the Israeli intelligence apparatus, as it was largely geared toward establishing a space-based military and surveillance infrastructure. For a country with as many enemies as Israel, a robust space capability is of the utmost importance. While Dr. Richest may not have been directly employed by Israel's intelligence agencies, he was no doubt heavily in support of them in his duties with Israel's space agency. Given the extremely crafty nature of Israeli intelligence operations, amongst the most legendary in the world, it's not at all unbelievable that Dr. Richest is merely fulfilling one final task on behalf of the American and Israeli intelligence services, disseminating disinformation to act as a cover story for current and future secret programs. As he has himself stated publicly, he's 87 years old and no longer cares about his reputation. The claims of human-alien cooperation are also dubious at best. According to Dr. Richest, American astronauts work side by side with aliens in a secret base on Mars, conducting research together. If an alien species is intelligent enough to cross the galaxy and get to us in a timely fashion, then what possible use are humans to them in conducting research? Even their calculators would be smarter than us. Having humans assist spacefaring aliens in research would be like inviting a wild chimpanzee into a research lab to help develop a COVID vaccine. Given humanity's behavior throughout 2020, both scenarios would likely involve equal amounts of poop throwing. But what if the claims are real? Well, there might be quite a lot of factors proving Dr. Richest's story is actually true. First, we have Dr. Richest himself, a career military professional, co-founder of a space agency, respected academic, and no history of mental illness or delusions. He served with the Israeli space program for nearly 30 years, receiving the Israeli Defense Award 3 times, twice for technological inventions that remain classified to this day. The doctor is clearly intelligent and possesses a high amount of integrity. Nobody lasts as long as he has in high-security clearance work without impeccable integrity. In short, if anyone was gonna leak the news that aliens are real, then Dr. Richest is quite literally the perfect, most trustworthy candidate to do so. The only possible way this announcement could have been more believable is if the claim was made by a serving head of state themselves in an official capacity. What we have here is one step short of the perfect witness, which makes it curious that his claims are so easily dismissed. Ask yourself the question, who would you believe if not a man of Dr. Ashed's qualifications? But Dr. Ashed isn't alone in his belief of extraterrestrials. In a 2014 interview with Jimmy Kimmel, former President Bill Clinton said that he wouldn't be surprised if aliens visited the Earth. However, he denied knowledge of actual aliens recovered from Roswell or being held in Area 51. He's hardly the only member of his administration with a belief in aliens though, with John Podesta, President Clinton's former chief of staff, making his belief in visiting extraterrestrials very public. But much as his former boss, stopping short of confirming any knowledge in government involvement. Two of the most shocking claims of aliens visiting Earth, however, come from political leaders in Canada and Russia. In 1997, Kirsan Ilumzhinov, head of the Russian-controlled Republic of Kalmykia, said that he was shocked to discover a hovering UFO right outside his balcony. The aliens flew Ilumzhinov to space and showed him the truth about UFOs. His claims prompted a bit of political panic in Russia, with some questioning his fitness to remain in office, though curiously some of Russia's Duma members were concerned with the potential leaking of classified state secrets to alien beings, and asked for a direction on how to properly respond if approached by extraterrestrials. Perhaps even more shocking, though, might be the revelation of one of Canada's former defense ministers. Until today, the highest-ranked state official to reveal the potential existence of alien life on Earth. Serving from 1963 to 67 as a defense minister for America's polite top hat, Paul Hellyer shocked the world during a speech at the University of Calgary. Mr. Hellyer claims that aliens have been visiting Earth for thousands of years, and perhaps unsurprisingly don't seem particularly impressed with humanity. According to him, the aliens' chief critique of humanity is that we spend entirely too much time fighting each other, spend too much money on our militaries, and not enough on feeding the poor and helping sick people. According to Hellyer, aliens even walk amongst us, with up to 80 different species visiting the Earth, and some looking so human that we don't even notice. The good news is that most of the aliens seem to be benevolent and concerned over our previous use of nuclear weapons and that we might use them again in the future. Generally concerned over humanity's future, the aliens are waiting for humanity to mature before sharing advanced technology with us. However, several species have outright hostile intentions that we need to be wary of, though he declined to share any specifics on those evil aliens. Both of our previous figures have been painted as crackpots in the media, but our next witness is a real American hero and one of the few men to ever set foot on another heavenly body, with man-made technology anyway. Astronaut Edgar D. Mitchell is famous for landing on the moon and helping save the lives of all aboard the Apollo 14 mission as it descended to the moon's surface. However, in recent years, he's also come out with claims that aliens are not just real, but actively involved in monitoring mankind. Unlike other leakers, Mitchell, however, stopped short of claiming close cooperation between aliens and world governments, and has never claimed to have met one himself. Instead, Mitchell claims that his experience in both the U.S. Air Force and NASA put him in contact with many individuals all telling the same story. UFOs have been closely monitoring humanity, and especially its nuclear weapons. In fact, he believes that their goal has been to avert a nuclear war between the US and Russia, or then the Soviet Union. Mitchell's claims aren't solitary either. Over the years, dozens of nuclear facility and nuclear missile silo security, maintenance, and launch personnel have come forward, all claiming to have witnessed UFOs over nuclear facilities, and at times even shutting down nuclear missiles. In fact, the writer and researcher of this episode, having been former military and with a high security clearance, can confirm multiple sightings of UFOs over a nuclear facility, though has to stress that these were true UFOs, as in unidentified flying objects, not necessarily of an alien origin, simply unknown. Something seems to be out there, but whether it's alien or not remains undecided. Certainly evidence is mounting, however, that somebody on Earth is flying craft with unusual flight characteristics, as shown in now multiple videos declassified by the US Navy of their aircraft in pursuit of UFOs. But if these craft are truly alien or not remains unknown, though perhaps Dr. Jaime Shed has had the answer all along. The true mystery, however, might be why a man with such impeccable credentials as Dr. Ashed is willing to risk his reputation on such outlandish claims. We all need a bit of privacy now and again. It's your human right, after all, to go about your day and not be watched over all the time by some kind of Big Brother surveillance technology. As that technology improves, though, and since you willingly feed huge chunks of personal data in a connected device, to some extent Big Brother already knows a lot about you. But imagine a bigger brother is watching over us, surveillance that tracks humankind. That's not part of the world we know. Imagine the Earth is a kind of zoo and we're specimens to be studied. That might sound far-fetched, but there are some serious people who believe it to be true. Let us explain. There's this thing called zoo theory, which is sometimes called the zoo hypothesis. This theory tells us that there's a chance that we're being watched over by extraterrestrial life, but those guys are just not in the mood to tell us about it. We are animals living in their zoo. According to this theory, one of the reasons they don't come down here is that they want us to evolve naturally. Their superior intelligence would blow our minds. They might be looking down right now thinking, it's about time those guys stopped having wars and started sharing things, but they want us to evolve by ourselves. Then there's the Fermi paradox, which basically states that there are billions of stars in the Milky Way, and so the chance that humans are alone is pretty much nil. There just has to be intelligent life out there, and it must have technology that allows interstellar travel. Then you have to consider the universe outside of the Milky Way, and the number of stars is mind-blowing. Surely it's arrogant to believe that we're all alone, as if us little humans rule the universe. There's an organization called Messaging Extraterrestrial Intelligence, or METI for short. This group comprises of many scientists, and they get together to discuss the possibility of contacting aliens, or us being watched over by aliens. On their website, the first thing you see is a statement that says METI doesn't rule out the possibility of life outside of Earth. If you scroll down, you'll see their list of objectives, and the first one goes like this: to conduct scientific research and educational programs in messaging extraterrestrial intelligence and the search for extraterrestrial intelligence. Scientists from all walks of life that are in METI are doing things right now, such as working on interstellar transmission technology. If ET could phone home, maybe humans could develop such long-distance communication tech. They also discuss the Fermi paradox and something called the Drake equation, which takes into account the size and age of the universe and what might be in it. Again, these people are not conspiracy theorists getting high in parents' basements. They are scientists. The president of METI is one Douglas Vakoch, and he's a renowned astrobiologist. This science is concerned with the evolution of the universe. For a long time, he's been working on interstellar messaging, but he's also well aware that human senses might not exactly work with alien senses. Even if we could send messages to other galaxies, if we said, "Hey guys, how's it going?" it might not work out. In fact, one of the latest blogs on the METI website asks if human language is any way to try and connect with aliens. The writer asks, is it a good way to send information to beings who are likely to be very different from us, whose bodies, sensory capabilities, cognition, environment, and experiences may be very different from our own? Then if we send out a message in human language form, which language? She states that while the Voyager disk, which is aboard NASA's famous Voyager 1 and Voyager 2 spacecraft, might have lots of information on it in 55 languages, we might better try and communicate in signs, shapes, and symbols and numbers. What's on the disk, you might ask? Well, if aliens pick it up, they'll find images of nature here on Earth, as well as many sounds of nature. They'll hear a message from former US President Jimmy Carter and be able to get down with a bit of Morse code. They'll see images of humans doing things and listen to the likes of Mozart and Beethoven. Chuck Berry is also on there, but unfortunately, no Led Zeppelin. They actually wanted to put the Beatles on the disc, but the record company EMI wouldn't allow that. Yeah, it's true. So back to the zoo. Those guys at METI often discuss something called the Great Silence, which relates to the question of why do these galactic zookeepers keep out of our face? Well, it's like we said, if aliens are that superior in intelligence, if they came into contact with us, they'd mess with our heads. We'd have to reevaluate life itself, and this would cause chaos. Just imagine if one day your dog got up and said in perfect English, "Hey buddy, can we skip the walk today? I'm thinking about going to Rover's house to discuss Wittgenstein's theory of the talking lion." If that happened, we'd have to start rewriting a few books, so the aliens stay away. In 2018, at a METI meeting, they talked about the idea of us being quarantined by aliens. This is how one researcher at METI explained that. It seems likely that extraterrestrials are imposing a galactic quarantine because they realize it would be culturally disruptive for us to learn about them. It's kind of the same thing as talking dogs. If they got into contact, our culture and society reality would be so disrupted we would just collapse for a while. Just imagine if right now, as you're watching this, an alien spacecraft pops up outside your window. You're then informed that the world is an illusion and your consciousness is eternal and infinite. We bet you wouldn't clock in at work or go to school tomorrow. Some folks at METI also say that we haven't developed full cognitive abilities yet, that there might be another level of consciousness in our evolution. The famous, now deceased Terence McKenna believed that certain psychedelics could provide a glimpse of what was possible in terms of developing a higher consciousness. He once said the idea of aliens coming down in a metal ship is totally preposterous. He believed alien life could be already here, and they might actually be in psilocybin mushrooms hidden in the very atoms of the things. He said those mushrooms are disguised as a drug, but might really be aliens. They are here, according to him, but we just don't get it yet. This might sound crazy to you, but serious scientists are now talking about the mind-blowing substance dimethyltryptamine, DMT, which takes people to places that are out of this world. Yes, lots of people visit aliens on their colorful trips. Research has shown that some people are absolutely convinced they saw aliens. This is why scientists at Johns Hopkins have been studying those breakthrough trips. We found more scientific research in the US that is taking seriously the possibility of DMT shooting people to another universe. In the mind, anyway. We're not saying this is proof that aliens are among us and we're being watched by them, but it's interesting that science is taking DMT so seriously as of late. Joe Rogan must be very proud, because any chance he gets he mentions his DMT experiences. He certainly wouldn't dismiss the alien contact theory. Then there's this theory. Maybe millions of years ago aliens detected life on a blue planet, the one we call home. They thought, let's send some signals to that place and see what happens. But let's just say that vampire squids and the Gojirasaurus weren't up for chatting. We weren't evolved just yet. We pretty much spent most of our time eating, fighting, procreating, and pooping. The aliens had to wait. So what did they do next? Once they'd been snubbed by basic life on Earth, they sent a probe here and bugged a rock. Why, you might ask? The answer is they wanted to keep an eye on us. Back to the zoo theory thing. The rock they bugged, though, was what was called co-orbital, meaning that it flies around the Earth. If you want a good view of Earth, there's not much point in bugging a rock actually on the planet. A researcher named James Benford, who's also part of the Search for Extraterrestrial Intelligence group, came up with this idea. Why does he think that? Well, it seems like quite the long shot. Well, it's not that he's certain, but it would make sense. What he's saying is that why not go check out some of those co-orbitals and see if any of them have not been bugged. Another researcher wrote, if it costs very little to go take a look, why not? Even if we don't find ET, we might find something of interest. The closest one is about 38 times further away from Earth than the Moon. We call it the Earth's closest companion, and NASA has said that it's not going anywhere. Well, we mean it's gonna hang around near Earth for centuries to come. That's why some folks are saying we need to do some more extraterrestrial archaeology. Start digging, NASA, because there might be a chance that we're part of an alien-led surveillance state. You might think that it's very hard to send a spacecraft that far, but from what we can see, it's not that hard. In fact, China said it'll send a spacecraft to Earth's closest companion in 2024. The spaceship Chang'e will be equipped with robots that will do a bit of digging around. Maybe they'll come back with some bugs and blow our minds. But if there's a trade war still going on, you can expect the Chinese not to share in the spoils. If in 2025 China suddenly starts speaking alien, you know how it happened. Some of those researchers really do think that those space rocks might be bugged, and they are the best chance we have of finding out if we're in a space zoo. One scientist said, if we don't find anything, that means no one has come to look at life of Earth for over billions of years. That's a big surprise, a stunning thing. When you consider what we've done over our 10,000 plus years of being fairly civilized, imagine what a species could do given a million years. Imagine what we will be capable of in a million years. Yes, we'll be all over the universe. There are things we'll achieve that we can't possibly imagine now. Imagine telling a guy in the dark ages about a show you watch online called the infographic show. He could not possibly envision the future, and neither can you. With that in mind, maybe a super civilization did visit us a long time ago. Maybe we're just slow to get out of the blocks. The idea of there being these super civilized space folks has been embraced by a lot of our greatest scientists. Carl Sagan was one of those scientists, and here's a lovely quote from him. "The universe is a pretty big place. If it's just us, seems like an awful waste of space." So that's it, really. When you look up into the sky, just imagine someone has been watching us evolve. The big brother who's been around for millions and millions of years saw us crawl out of the swamp. They watched as we stood up and started making spears and drawing pictures of buffalo on cave walls. We hunted and gathered, and a few thousand years later, we started talking about gods that live in the skies. They must have loved that. Then they witnessed endless wars as we struggled to fight over land or which region was the right one. "Come on, guys," they thought. "It's us. We're your gods. Get with the program." They were astounded when we built bombs that could destroy an entire planet. They knew who killed JFK and why those guards were sleeping when Mr. Epstein ran out of air. They're confounded by President Donald Trump's Twitter feed, and they're keeping an eye on you right now as you get to the end of the show. We might also add that while it's very plausible that aliens exist and are watching over us, in terms of scientific proof, well, that's yet to come. The date is April 11th, 1970, and outside of the Kennedy Space Center, 3 men sit atop millions of pounds of explosive fuel. American astronauts James A. Lovell Jr., T. Kenneth Mattingly II, and Fred W. Hayes Jr. have been safely sealed into the crew module of their Saturn rocket 45 minutes ago and have spent that time strapped into their seats, awaiting the long list of final checks required before launch command is given. At last, Flight Control receives the all-clear from dozens of different department heads whose jobs are all to ensure a successful launch. And at 2:13 p.m. Eastern, the massive Saturn rocket roars to life. Almost 5 million pounds of fuel ignite, and the mighty Saturn slowly lifts off the launch pad, gradually increasing speed. In moments, the crew is already breaking the sound barrier, roaring into the heavens on a mission for the next manned landing on the moon. The rocket is a multi-stage vehicle that conserves fuel by gradually shedding spent stages and thus lowering the total mass that needs to be lifted up into orbit. This allows the Saturn to achieve the fuel efficiency required to bring significant loads, such as the Apollo spacecraft itself, into orbit. But it's not without its risks. According to the plan, the first stage burns for 2 minutes and 41 seconds, shooting the rocket to an altitude of 42 miles at a speed of 6,164 miles per hour. At that point, explosive separators would disengage the first stage from the second stage, shedding tens of thousands of pounds of dead weight. The second stage's 5 engines would then flare to life, accelerating the spacecraft for 6 minutes to a height of 109 miles and 15,647 miles per hour, which is almost orbital velocity, or the speed needed for an object to remain in orbit. Then the second stage would separate, and the third stage would fire to put the spacecraft on a parking orbit around the Earth. At that point, the Apollo Command and Service Module would detach from the third stage, turn around and dock with the Lunar Module, which was secured right below the CSM during launch, and extract the Lunar Module from the spent third stage. All of this required an incredible amount of careful engineering, and with millions of moving parts, anything could go wrong at any time. For the astronauts of Apollo 13, though, those first few seconds after engine ignition were the most terrifying, as all aboard knew that if the engines failed while they were still only a few feet off the ground, the entire rocket would come crashing down, and the millions of pounds of fuel would incinerate everything. In fact, the fully fueled Saturn vehicle could release an energy equivalent to 2 kilotons of TNT if it failed at liftoff, giving the astronauts on board no chance of survival. Yet today, the rocket seems to be working fine, and in moments the crew is breaking the sound barrier and speeding toward their first stage separation. Almost 3 minutes later, the crew hears the explosive bolts fire off as the first stage is successfully cast off, and a moment later they're kicked back into their seats as the 5 engines of the second stage fire off. Carrying a much smaller payload, the engines quickly accelerate the spacecraft, pinning the astronauts to their seat. Yet in what would turn out to be a precursor for the doomed mission, the center engine suddenly shuts down as alarms ring both on the ground at mission control and inside the command module. Unbeknownst to the engineers on the ground and the astronauts aboard, the flight computer has automatically shut the engine off due to several oscillations caused by uneven burn of that engine's fuel. If left unchecked, the uneven thrust could produce even more severe oscillations, which could lead directly to mechanical damage and possibly outright destruction of the engine. Luckily for the crew though, the computer has detected the pending problem and shut the engine off just in time. But even more luckily for the crew, the afflicted engine is the center engine. Had it been one of the 4 outboard engines, the spacecraft could have tumbled out of control. At the speeds Apollo is now traveling through the atmosphere, that would have ended in certain death as wind resistance shredded the spacecraft. To compensate for the loss of the center engine, the computer replots its flight profile and burns the 4 outboard engines for longer than planned. As the second stage separates and is cast off, the third stage's single engine burns longer than originally planned as well, to compensate for the lost engine in the second stage. And though fuel margins are incredibly tight, luckily the spacecraft has enough fuel to compensate for the emergency. Well over 100 miles over the Earth, the spacecraft is now in a parking orbit, and the crew runs system checks and prepares for their burn window to send them to the moon. When some final checks sound the all clear both on the spacecraft and on the ground, the third stage begins its trans-lunar injection burn. After a successful burn sets Apollo on a non-free return orbit to the moon, meaning the spacecraft won't simply swing by the moon and be pulled back to the Earth. The command module separates from the third stage and, as planned, spins around to dock with the lunar module, which is then released from the third stage. Moments later, the command module makes a small burn to alter its own trajectory. The original translunar injection burn has put the third stage directly on a collision course with the moon as part of an experiment that NASA plans on conducting. The third stage is plotted to impact within just a few kilometers of where Apollo 12 had deployed seismometers, with the resulting seismic shock giving NASA scientists insight to the inner structure of the moon. The astronauts are now safely on their way to the moon and broadcast live to the world below. After their brief TV broadcast, the astronauts remove their heavy pressure suits and settle in for the long 3-day ride to the moon. Their goal is the Framaro Highlands, a region fraught with hazards as it's rather hilly and will make landing challenging. Yet the site promises to hold a treasure trove of geological data, as it's full of ejected debris from the impact that had formed the huge Mare Imbrium lava plain, the remains of one of the largest craters discovered in the solar system, and the iconic large dark spot visible to us every night on the moon's face. 30 hours into their flight, the astronauts light up the command module's engines for a small mid-course correction in order to fine-tune their final orbit around the moon. All is still well aboard the spacecraft, and on the ground all systems are reading green. The historic mission is set to be the success that all of the USA's previous moon landings have been to date. 56 hours into the mission, Apollo 13 is 205,000 miles from Earth. The astronauts have just ended a live TV broadcast and are stowing the equipment when flight controllers ask command module pilot John L. Swigert to turn on the stirring fans inside the hydrogen and oxygen tanks in the service module, which would help them get even more accurate readings on their levels. 2 minutes later, there's a large bang, and the electrical power inside the command module begins to fluctuate wildly. While outside the spacecraft, the attitude control thrusters fire briefly. In what have become the second most famous words ever uttered in space, Swigert radios home, saying, "Houston, we have a problem." Electrical power is slowly being drained from the service module, and oxygen tank number 2 reads completely empty. The astronauts are confused and initially think that they may have been struck by a micrometeorite, not realizing that one of the oxygen tanks has exploded. On the ground, NASA technicians and engineers have been recalled to mission control from home and their offices, the situation already looking dire. 3 minutes later, 2 more fuel cells fail, plunging power levels in the service module to critically low levels. Outside the window, astronaut James Lovell can see that the spacecraft is venting gas into space, likely oxygen. Over the next 2 hours, the main oxygen tank also depletes until finally running empty. The crew is in serious trouble and desperately needs a way back home. Lead Flight Director Gene Kranz officially orders an abort of the mission, and engineers on the ground begin scrambling to find a way to provide enough power to the remaining fuel cells to save the astronauts' lives. With the service module, which was meant to return the crew to Earth, out of commission, the flight engineers fall back on an abort plan originally drawn up in 1966, but never actually put into practice or even tested. The crew will shut down all systems aboard the command module completely and move into the cramped lunar module, which they'll then use as a lifeboat to get them back to Earth. Designed for only 2 astronauts, the ride is not going to be comfortable for the 3-man crew, but it's the only chance the crew has to get back home safe. The original plan for an abort, though, had called for the jettisoning of the lunar module entirely and burning the command module's engines at exactly 60 hours flight time in order to achieve a free return lunar flyby. However, the crew would die without the lunar module, so the planned burn is scrapped. With the moon's sphere of gravitational influence just a few hours away, flight planners have to work fast to figure out a way to bring the crew home using the lunar module. Yet there's another critical problem to solve as well. The lunar module was designed to sustain 2 people for a day and a half. not 3 people, for 4 days as it now needs to. The spacecraft still carries plenty of oxygen, as the lunar module had to repressurize after each EVA on the moon's surface, but the lithium hydroxide, which is critical for removing carbon dioxide from the atmosphere, is in short supply. Most of the lunar module's lithium hydroxide canisters are stored on the descent stage and out of reach of the astronauts, who cannot conduct a spacewalk to retrieve them. If a solution is not found swiftly, the crew will asphyxiate long before returning to Earth. The command module has enough lithium hydroxide stores to safely clean the crew's air supply, yet the CM's canisters are cube-shaped and the lunar module sockets are cylindrical. As NASA engineers go into a flurry of brainstorming to figure out a solution, Flight Control works on figuring out a safe return trajectory for the stricken spacecraft. Flight Director Kranz orders the crew to burn the lunar module's descent engines for 30 seconds. This will allow the spacecraft to slingshot around the moon and be hurled back to Earth. And after a second burn on the far side of the moon, Apollo 13 would be on its way for a splashdown in the South Pacific. But if the crew can't breathe, all the US Navy would be recovering from the spacecraft are 3 perfectly preserved corpses. Inside Mission Control, NASA engineers furiously work at solutions to the lithium hydroxide problem, gathering together a store of all materials available to the astronauts themselves. With just hours of clean air left, an ingenious solution is found. The crew is ordered to cut off one of their spacesuit's air hoses using tape, Velcro, and other odds and ends. Fashion it into an adapter for the cube-shaped lithium hydroxide canisters from the command module. Much to everyone's relief, the improvised solution works brilliantly, and at last the crew of Apollo 13 sees some real hope of returning to Earth safely. Yet the crew is not out of the woods yet. To conserve very limited power supplies, most of the lunar module systems and all of the command module's computers have been shut down. This means temperature control as well, and the plummeting temperature has the crew shivering. Even more dangerous though, condensation has begun to form on the inside of the stricken spacecraft, and there are serious concerns that when the command module is powered up, it will cause catastrophic electrical shorts. To add to the astronauts' worries, the command module was never designed to be completely shut down in flight and then restarted. With time running out and power at too low of levels for a normal power-up routine, Flight Controller John Aaron and astronaut Kenneth Mattingly, who was originally supposed to be on board, work with engineers to figure out a way to restart the power-hungry command module with the limited power supply available. Working tirelessly and without sleep, the ground team manages to figure out a way to restart the CM systems while avoiding unnecessary power draws. With the Earth in their sights and re-entry just a few hours away, Apollo 13's crew begins to power up the CM per Houston's very careful instructions. Back on Earth, the ground team holds its breath as Apollo 13 systems come back online one by one, and then explode into cheers as the command module comes fully to life. Yet, as the Earth looms large before the astronauts, one final challenge remains. The lunar module must be safely separated from the command module before re-entry, or both vehicles will burn up in the atmosphere. Typically, the service module's reaction control system would fire off a small series of thrusters to gently pull away from the undocked lunar module. Yet the power failure has left the RCS system inoperable, and the now useless service module was going to be released before the lunar module anyways. On the ground, NASA engineers in conjunction with counterparts at the University of Toronto conclude that the only way to separate the command module from the lunar module would be to pressurize the tunnel connecting the two just before separation. And once separated, the rush of gases venting into space would push the lunar module away. Yet the ground team has to carefully calculate the exact pressure required to do so, as too much pressure will damage the command module's hatch and seal, leading to the astronauts burning up in the atmosphere. Too low pressure would not push the lunar module far enough away, putting the two craft at risk of collision during re-entry. Using just slide rules and with 6 hours before atmospheric re-entry, the ground team led by Bernard Etkin work furiously at their calculations. With an hour left, the exact figure is radioed up to Apollo 13, and the astronauts seal the hatch to the command module, venting oxygen into the tunnel that connects them to the lunar module. The astronauts hold their breath as they prepare to undock, knowing that if the calculations are wrong, they are certainly dead men. And with no way of averting atmospheric re-entry anymore, they'll have a long time to think about their certain death. At last, the lunar module is undocked, and with a hiss of escaping air, the vented oxygen successfully pushes the lunar module away to a safe distance. Apollo 13 would go on to splash down just southeast of American Samoa in the South Pacific, easily the most harrowing mission ever undertaken in manned spaceflight. Apollo 13 may have been a technical failure, but was a complete success in testing mankind's ingenuity and resolve in the face of incredible odds and adversity. More than a successful mission ever could have, Apollo 13 proved that mankind truly has what it takes to make the bold move into space so vital for our shared future. Even if, sadly, just a few years later, the United States and other nations of the world would seemingly lose all interest in ever visiting the heavenly bodies above us ever again. Space, the final frontier. It's a merciless void full of cosmic phenomenon hell-bent on killing you. The single most uninhabitable environment in the universe. Just to reach it demands the very best of nations, the finest engineering, the most intelligent scientists, and the bravest, most upstanding of astronauts. With not just lives but hundreds of millions of dollars at stake in every launch, the astronauts who represent their home nations also represent the very best of that nation. Yet despite this, it seems we're all fallible and prone to crimes of passion. That's right, the first ever space crime has finally been committed, and some people are wondering exactly how this is going to work, really. You've probably seen a Hollywood movie or two where the crooks try to make a break for open sea. Once out in international waters, they can't be convicted of criminal acts. After all, nobody owns the open sea, right? Well, that's only half true, because nobody in fact does own the open sea, and it actually belongs to everybody. That, however, does not mean by any length that you can get away with crime scot-free. See, long ago the international community got together and agreed that there had to be a legal framework for crimes committed on the high seas. The problem was whose laws should be followed in open waters, and if one country's laws were enacted everywhere, then wouldn't that sort of violate the whole nobody owns the open ocean thing? To simplify matters, the world agreed to some basic maritime laws that all nations would adopt and be applicable to ship traffic anywhere in the world. But for individual crimes, it was decided that national law would dictate if what you did was a crime or not. Basically, whatever nation a ship is registered in, then that's the country whose laws will be enforced on board that vessel. So if you committed, say, murder on the high seas while aboard a Pakistani ship, you would be tried and punished under Pakistani law, regardless of your own nationality. Thankfully, nations generally agree on the big don'ts of the 10 Commandments. So there's not a nation you can register your ship with that'll let you throw giant murder parties and get away with it. Less fortunately, there's a huge disparity in other laws that govern other issues, such as safety and worker compensation. That's why most big transport vessels are actually registered in Panama, the Marshall Islands, and Liberia, as it allows their operators to pay their crews less and pay less taxes overall. Now we turn our focus to space, and the world's first bona fide space crime. Annie McClain is an astronaut and former U.S. Air Force combat pilot with over 800 flight hours in a combat environment. Recently, however, she was on a 6-month mission to the International Space Station, and while aboard the ISS, committed the world's first space crime. Back on Earth, McClain and her partner had been undergoing a very messy divorce. In order to keep tabs on her partner's financial activities, McClain used the ISS's internet connection to log into her partner's bank account, despite the fact that at the moment the two were in the middle of a divorce. She used the information to confront her partner about several aspects of the divorce's settlement, and in turn, McClain's partner filed a criminal complaint against her. According to her partner, McClain improperly accessed her finances and stole her identity, so to speak, in order to gain access to those financial records. McClain counters by saying that she was simply overseeing their joint finances, as she had often done while they were married. However, as of this episode, this is all still just allegations, and because we don't live in China, McClain is innocent until proven guilty. Granted, it's not as exciting as smuggling dilithium crystals or even space murder, but inappropriately logging into someone else's secure bank records is still a pretty serious crime and can in fact be construed, legally speaking, as identity theft. Punishment varies on a state-by-state basis, but identity theft is a felony in every state in the Union. In Georgia, for example, you can receive up to 10 years in prison. This, however, raises a rather curious point about McClain's crime. What state exactly would she be tried in for a crime committed from outer space? While in space, all astronauts are governed by national law, no different than if they were on the high seas. On the ocean, though, McClain would have faced the consequences for whatever state her vessel was registered in the United States. But in space, the International Space Station is, well, international. While astronauts themselves are governed by the law of their home country, details get murky in this case as far as what state should McClain be tried in if found guilty of identity theft. In some cases, the federal government steps in, especially if identity theft charges are brought against someone who has committed the act across several states. But this is usually reserved for big-time offenders, such as major hackers or criminal figures whose actions might span across the entire nation, and in fact the world. McClain wasn't even in the world when she committed her crime though, so who's gonna punish her and under what jurisdiction? This is of course assuming that McClain is found guilty, which is being investigated now. NASA's Inspector General itself is looking into the matter, and likely there will be no charges filed as the evidence against McClain may be a bit weak. Most married couples, after all, do know each other's financial record information. Still, this whole case has got many people back on Earth thinking about the consequences of humanity's ever-expanding presence in space. Even now, Elon Musk is preparing to test a rocket that could take dozens of people into orbit and beyond per launch. He has repeatedly stated that his ultimate goal is human colonization of the solar system. Will these new human colonies follow the laws of their home countries too? Or should they be allowed to create new laws and govern themselves? What claim does Earth really have on people who live so far away it takes years and hundreds of millions of dollars just to get to them? These are all questions that humanity is going to have to start answering very soon indeed. And it may be interesting to think that though the first colonies in space may be American, Russian, and Chinese in origin, their distance and difficulty in physically getting to these colonists may see them declare independence. Perhaps Martians are already amongst us because some of Earth's children may grow up one day to go live on Mars permanently, eventually deciding that they want to govern themselves. Whatever the future holds, one thing is for certain: humanity is going to take its best to the stars along with its many vices, and we'd better be ready to deal with the consequences. A month prior to takeoff. It's been less than a year since the US put a man on the moon, and astronaut Neil Armstrong said those words. That's one small step for man, one giant leap for mankind. The US wants to do it again and perhaps have an astronaut say, "This is another small step for man," although admittedly it won't be the same kind of leap for mankind. That shows how little interest the US public is paying to the Apollo 13 mission. When Apollo 11 took off on July 16, 1969, the entire world was watching. Neil Armstrong, Buzz Aldrin, and Michael Collins would become household names for many years to come. The images of them walking on the moon would forever be implanted into people's minds, and when Armstrong said the Eagle has landed, people all over the globe were half-baked on beer at their house parties, celebrating as if they've just won the lottery. Things were not exactly the same when the Apollo 13 mission was announced. If you'd had picked up a newspaper in 1970, you'd have had to turn a fair few pages to read about the mission. It seemed that the hard-to-please public was not that impressed with spaceflight anymore, and you can bet that not many people knew the names of the astronauts James A. Lovell Jr., John L. Swigert Jr., and Fred W. Haise Jr. But while the US public is less interested in these guys, at this point in time, their mission is about to break new ground. People will flock together in their living rooms again, but there won't be much of a party atmosphere this time. That's because something terrible was about to happen. It has to be said, though, that the mission's horrific nature will make people interested in spaceflight again. Hour 0. As the crew's readying for takeoff, the families and relatives of all three men are excited but nervous. The astronaut Jack Swigert shouldn't have even been there. He's just replaced another astronaut due to the other guy coming down with rubella, aka German measles. This is the first thing that has gone wrong. Swigert at least doesn't have a wife at home or any children to worry about. That can't be said for Fred Haise, who, like Swigert, has never been to space before. Haise's 9-year-old son, Steven, doesn't quite understand the implications of what his daddy is doing, although his pregnant wife certainly is feeling the pressure. In a few days from now, she's going to be rubbing that bump on her stomach, wondering if in years to come she's going to have to explain to this child why she never talked her husband out of going on that mission. After all, she is well aware of the dangers involved in sending humans to space. What she doesn't know is that they are traveling in what is essentially a bomb. As for the commander of the mission, Jim Lovell, you could say he has more to lose than everyone. He has 4 kids with his high school sweetheart, Marilyn. Their daughter, Barbara, is 17, and she understands the gravity of the situation, pun intended. Their son, James, is 15, Susan is 12, and Jeffrey is just 4. The entire family will soon hear that their beloved husband and father might freeze to death or die slowly as his oxygen runs out. It's going to be a hellish few days for all of them. Everyone except the 4-year-old knows what happened in February 1967 when Apollo 1, supposed to be the first spacecraft flown into space with the intention of landing on the moon, didn't quite get there. All 3 men were incinerated in the cabin during a launch rehearsal. With spaceflight, there are literally a million things that can go wrong, perhaps no more devastatingly exemplified than in the 1986 space disaster, when 7 U.S. astronauts died just 73 seconds after takeoff. In short, the families of these 3 men in Apollo 13 are proud as hell, but right now, their nerves are as frayed as Charles Manson's mind. Hour 1. The Saturn V rocket they're sitting in at the Kennedy Space Center is about to take off. Mission Control does the countdown. 10, 9, 8, ignition sequence is started. 6, 5, 4, 3, 2, 1, 0. And we have liftoff. The time is 2:13 Eastern. Destination the moon, or more specifically, the Fra Mauro crater area. 200,000 people who've come to watch the liftoff feel the ground shake as the 160 million horsepower beast leaves for the skies. That's not a bad turnout, but nothing compared to the 2 million that were there when Apollo 11 lifted off. People watching the event on television near Mission Control say the Saturn V, building up to 7.6 million pounds of thrust, has cleared the tower. Another voice says, "This is Mission Control, Houston. We appear to have a good first stage at this point." People are told the trajectory is looking just fine as the rocket powers on. Mission Control lets them know that 1.2 miles into the sky, the spacecraft is traveling at 1,500 feet per second. At home, the men's families jump for joy, but they don't know that something isn't quite right up there. At about 5.5 minutes, the center engine of the S2 stage shuts down. This isn't good at all. It shut down 2 minutes early. It means that the remaining 4 engines have to burn 34 seconds longer than has been planned, and that the S4B third stage engine has to burn 9 seconds longer. That all has to happen for Apollo 13 to get into orbit. Mission Control isn't happy, but everyone knows that there will always be something that doesn't go exactly to plan. They're just hoping that this little glitch will be the worst thing that happens on the mission. It's not by a long shot, but the next few hours and the hours after are all smooth sailing for the crew and ground control. Hour 30. The 3 astronauts are fooling around, talking about their appearance while doing a bit of facial grooming. Jack Swigert makes a joke, saying something along the lines of "hello to all the girls." The mood is good among the men. They're told some golf scores, and then Jack goes into detail about how they get rid of their pee in the spacecraft. The transmission between the guys is what's called the Capcom, or the capsule communication. The astronauts on Earth who keep in touch with the crew all the time. They take the Capcom job in shifts. Hour 46. Nothing major is happening right now. At some point, a guy named Joe Kerwin, who's the main capsule communicator at this point, reports, "The spacecraft is in real good shape as far as we are concerned. We're bored to tears down here." Just after he says that, the master alarm sounds and scares the hell out of everyone. It's a false alarm, though. The guys then listen to a song as Kerwin winds them up by sarcastically telling them space looks great and that they have all the comforts of home. He's well aware that space travel is extremely uncomfortable. Hour 47. The crew talks about a problem with the hydrogen tank, after which they discuss changing their flight plan. There's also a problem with the command module, but it's nothing to write home about. The mission's still going according to plan. Hour 52. The new Capcom guy, Vance Brand, jokes with the crew. Everything looks normal, so they can afford to kid around. Right now, they're traveling at 2,323.4 miles per hour and are about 170,000 miles from where they took off. Hour 55. Things are so under control that the crew starts a live TV broadcast for the folks back on Earth. As interesting as this should be, quite a lot of TV stations are not even showing it. It's as if people just aren't interested in space anymore. Hayes tells the people at home how they sleep and how they drink water. These guys tease each other, as they always seem to, and then they put on the song "Willow Weep for Me." They're making space travel look like a walk in the park, albeit something you wouldn't want to do if you were claustrophobic. At 55 hours and 45 minutes, Hayes goes up behind Lovell with a repress valve scaring the hell out of him. Lovell tells the new Capcom, "Every time he does that, my heart jumps into my mouth." It's at this point that the TV transmission ends. Lovell is the one who signs off, telling people back home, "This is the crew of the Apollo 13 wishing everybody there a nice evening, and we're just about ready to close out our inspection of Aquarius and get back for a pleasant evening in Odyssey. Good night." Aquarius is the lunar module, and Odyssey is the command module. We'll talk more about this soon. The people down on Earth have just witnessed what looks like a bunch of very smart men acting like teenage kids, pranking and teasing each other all the time. It seems to them that space travel isn't frightening at all. Hour 56. The crew has just heard an explosion. It sounded like someone hitting a large piece of metal, followed by a crinkling sound, like someone squashing a rather large can of Coke. This is when Swigert says, "Okay, Houston, we've had a problem here." They look at the oxygen tanks and fuel cells. What they see is alarming. Oxygen tank 2 has little to nothing in it, and oxygen tank 1 looks like it's about to run out. Mission Control responds by saying this is likely not what's happening. They say the gauge readings might be faulty. Lovell explains that he's pretty sure he can see gas leaking out of the hatch. It's not quite panic station time yet, but something is wrong. And it doesn't seem to be a minor something like the earlier issues. This is serious. Lovell says, "We're venting something out into space. It's a gas of some sort." What they don't know just yet is that there's been a short circuit in oxygen tank 2, which basically ignited a bomb. It exploded when Swigert started what's called the stir, which stirs the contents of the tank, and this caused a 13-foot panel to blow off the service module. The two main parts of the Apollo spacecraft are the command module and the service module. The command module is where the cabin is and where the crew lives. It's where much of the equipment is and where many controls and displays are. This is a cone shape. The service module is where they store lots of equipment, but it's also where they get propulsion from and electrical power. It's shaped like a cylinder. They're both connected by a kind of umbilical cord. As for what's gone wrong, it'll become known that there was a design error. You see, the command and service modules were supposed to operate at 28 volts, but years before these guys took off, when tests were happening at the Kennedy Space Center, it was decided that 65 volts would be better, so engineers were told to redesign the components to run at both levels of voltage. So far so good, but the problem was the oxygen tanks. These are not only for the men to breathe, but to also help run the fuel cells that give power to all the spacecraft's systems. So in short, there's a thermostat in those oxygen tanks to ensure that the temperature inside them is regulated. But the company that made the thermostats had not gotten the memo about the new voltage change. This might not have been such a big issue if it weren't for the fact that during the design stage of the tank, someone had dropped tank number 2. But as it didn't seem damaged and did fine during further tests, it ended up going to space with the other tanks. Nonetheless, after it had been put inside Apollo 13, it wouldn't empty during some other tests. That's because when it had been dropped, the instrument that did the emptying had been damaged. Technicians managed to find a way to make things right, but by doing so, they heated up the tank so much that some of the insulated wires were damaged. If that makes little sense to you, don't worry. You can't all be rocket scientists. All you really need to know is that Apollo 13 left Earth with an unstable tank inside it, making it a flying bomb. When Swigert was ordered by Mission Control to stir the contents of the tanks by hitting the stir button, what he or no one else could have known was that the previously damaged insulation wiring caused a spark. We don't need to tell you that a spark inside an oxygen tank is generally not a good thing. The oxygen fed the fire, and the pressure became so much that the tank exploded, wrecking not just it but many of the things inside the service module. The 3 astronauts were now 200,000 miles from home in a spacecraft that was missing some of its vital parts. Hour 57. The Capcom, now Jack Lausma, tells the crew that the oxygen tank is leaking badly. He tells them it's slowly going to zero and we're starting to think about the LM lifeboat. Swigert replies, "That's what we've been thinking about too." Okay, we should explain something else. The LM means lunar module. This is the part of the spacecraft that's supposed to ferry the astronauts to the moon. It's connected to the command and service modules. It was the part of Apollo 11 that you saw sitting on the moon, or landed in a movie production studio for some of you wild-eyed people. In this case, the astronauts are thinking they could use it as a kind of lifeboat. It's never been done before, but hey, without electricity, they'll either freeze to death up there, or without oxygen, they'll slowly move toward that thing we call brain death. The mission is aborted. It's now time to think about getting home. But with so little power, they have to power down the command module. It'll get very cold in there very soon. Even though escaping in a lifeboat doesn't sound so safe, the astronauts seem to be taking it all in stride. They later say they weren't thinking about death, but just getting the job done. Much more is about to go wrong, though. Hour 58. Lovell jokingly tells Mission Control that he wasn't expecting to return to Earth so soon. No one laughs. His wife is now at home, worried out of her mind. She's been informed about the problems, and she knows he and the others have to make an emergency return. It's fortunate for the men that the explosion didn't happen on the way back home, because then there wouldn't have been a lunar module to use. They all would have died without a doubt. But even now, things are looking grim. No one has ever tried anything like this before. Hour 59. The crew makes their way to the lunar module. Given that they now only have 15 minutes to get out of the command module, the power is almost gone, and no power means death. Hayes and Lovell float through the tunnel to the lunar module while Swigert stays behind to ensure everything is turned off. There are a few things they have to bear in mind. The lunar module is only supposed to have a 45-hour lifetime, but they need at least 90 hours. They should have enough oxygen, and even if the tank runs out, there are 2 backpacks full of oxygen that were supposed to be used for walking on the moon. There are also backup packs of oxygen for those packs. Food is a concern, or a lack thereof, but water and temperature are a much bigger concern. They don't have much of either. Still, if they don't power down, they won't have the power to get back to Earth. That's why all non-critical functions are turned off. Hour 61. It seems the men are in good spirits. Lasma, who's still Capcom, teases Lovell, telling him not to worry, this is all just a training exercise. Hour 67. The men are informed that President Nixon has been told about what's going on. Mission Control is currently in talks with the White House. When Nixon is asked if he'll listen to updates, he responds with, "Yeah, go ahead and throw it to me." Hour 68. Press conferences are held and the general public now knows there's been an explosion and the astronauts have no choice but to come back. It's about this time that Lovell is heard saying there probably won't be a lunar mission for a long time. Another major problem is the course they're going to take. They were supposed to land on the moon and then go home. Going straight back was never on anyone's mind. The command module navigational platform has been transferred to the lunar module, but that doesn't mean they can easily verify where they are. They believe that the service propulsion system on the command module that could have them thrust back is now broken, so they decide to go around the moon and come back that way rather than just thrust back. They're literally going to swing around the moon. Space isn't the kind of place you can just do a U-turn, so this is the better option. They have the lunar module's descent propulsion system, but the crew and ground control now have to make a lot of difficult calculations. It's fortunate that before Lovell left the command module, he copied down all the important information from the module's guidance system. They will need to do another burn once they're around the moon. If they aren't able to do this, for some reason they'll go on a different trajectory and miss the Earth by thousands of miles. Also, when they do that flight around the moon, they'll have no contact with the people on Earth. But the good news is, during this quiet time, they look out of the windows in awe, snapping pictures like space tourists. Hour 79. It's now or never. NASA has chosen a 4-minute burn which will shave 12 hours off the flight and hopefully land them in the Pacific Ocean. Hour 80. Lovell's family is at home, now joined by the astronauts Pete Conrad, Buzz Aldrin, and Neil Armstrong. Hour 81. Lovell talks about food and water again. The crew decides that their best chance of surviving is if they consume 1/5 of their normal intake. They'll eat hot dogs and wet pack food. They know they'll become severely dehydrated, but there's nothing they can do about that. They can only drink just 0.2 liters of water a day if they want to make it back home alive. The entire crew will lose a total of 31.5 pounds on this return trip. Hayes even develops a urinary tract infection. The men have already decided not to drink their pee or even throw it out into space. They put it in bags, believing that they could upset their trajectory if they throw it out. Hour 82. The men are freezing. It's now 38 degrees Fahrenheit. It's dark and they're hungry and thirsty. They think about putting on their spacesuits, but that'll make them too hot, so they just use anything they can find to cover themselves. They also slip on their lunar boots, which at least warms up their feet. Hour 85. During a press conference, NASA explains that it's worried about what consumables are left and says the rest of the journey is not going to be comfortable at all. Hour 90. Perhaps to cheer the guys up, the new Capcom asks Swigert about the new income tax rule when you're out of the country for a certain amount of time. It's just a joke, it helps with the men's morale. Hour 93. The lunar module is only supposed to carry 2 people. What that means is the canisters inside that absorb gas in the air won't absorb enough of it. This could lead to a dangerous buildup of carbon dioxide. It doesn't help that the command module uses square canisters, but the lunar module used round canisters, so they can't take the canisters from the command module and put them in the lunar module. This is a matter of life or death. The men put their heads together and with the help of ground control, they build new canisters out of plastic bags, cardboard, and bits from a lunar suit, as well as a bunch of tape. It works. The CO2 levels go right down. Hour 118. Lovell asks about the re-entry procedure. The reply is, "Roger that, we're trying to get the procedures to you right now." It'll be a few hours before they get the timeline and the sequence of events that are going to happen. Lovell waits a minute and explains that he's not a happy man. He's just found some hot dogs, but they're so cold that they're frozen. What's important here is that when they try to power the command module back up for re-entry, it'll be a completely unique operation. There are no procedures for this since no one has ever thought such a thing would happen. It takes a lot of effort and a lot of brains to figure out how to proceed with the re-entry. Staff on the ground work through the night running the simulators to better understand how to perform the re-entry. As NASA says at a press conference, they've tried to run everything they've asked the crew to do through their simulators. Everything that is non-normal, says NASA. Back in space, the men have thrown away the rule book, so to speak. They've never powered down a command module in space, and they've never powered one back up either. They need to re-enter since the lunar module will burn up on re-entry as it doesn't have a heat shield. It also isn't built for landing in the ocean. Hour 123. Mission Control gives Lovell the green light to fully power up the lunar module. This will raise the cabin temperature and also restart the lunar module's guidance computers. Hour 125. Lovell says they now have no water left. That's not good, but he has to grit his teeth and listen to the re-entry checklist. Soon after, he tells the other two guys what's going to happen. Hour 132. Swigert now tells the new Capcom guy that it's too cold to get any sleep. He's very tired now and thirsty, but no one's complaining. He just hopes they'll get home. Hour 138. The damaged service module is jettisoned. This is when they see just how much damage was done during the explosion for the first time. All the men realize how lucky they are to be alive. Minutes later, Swigert thanks Mission Control. Many calculations had to be made in quick time to ensure the module left them, and they were able to thrust out of its way. It wasn't easy by any stretch. Hour 141. The lunar module is just about to be jettisoned. They've waited for this, knowing that if it's not literally blown off at the right time and at the right angle, they might hit the ocean and skip like a stone. A mistake here could also mean a very fiery entry, or as Lovell said years later, burning up like a meteor. Down below, the US Navy is waiting to pick the guys up. Hour 142. The public is now glued to their TVs, not just in the US but all over the world. This has been some trip, a drama of the highest order. Talk about reinvigorating people's interest in spaceflight. It's actually a good day for NASA in terms of marketing. That is, if the guys get back in one piece. The men land in the Pacific without any problems. The world cheers so hard that the thing nearly falls off its axis. Mission Control tells the guys, welcome home. What's more, even with a partly destroyed mothership, their splashdown becomes the second most accurate in the Apollo program. Hour 143. President Nixon, tricky dick to some, gets on the line to Lovell. He asks, "Are you on the line alone? Are the other fellows on too?" "Yes, sir," says Lovell. Nixon says, "Getting elected as president was the biggest day of my life, but this one was bigger." He tells them that they'll all get a Medal of Freedom. It's a good day for the astronauts and a good day for Nixon's image. Lovell apologizes for not completing the mission, but Nixon rightly reminds him that they did something even better. They did something that has never been done before. Even so, Lovell's more concerned about his family back home. That's what really matters. He'd figured that much out when he was hurtling through space. President John F. Kennedy once shocked the world with the words, "We choose to go to the moon." By we, he meant America, and thereby insinuated that once astronauts got there, that the entire country would share in their success. Fast forward decades later, and Yusaku Maezawa, a Japanese citizen, said something almost identical yet critically different. With excitement, he said the following, "I choose to go to the moon." What was once a goal that brought millions together has now become something that wedges an even wider gap between the top 1% and the rest of society. Was he right? Let's look at the privatization of space travel in this episode of the Infographics Show. Is SpaceX creating a world for only the rich? Yusaku Maezawa is not just anyone. He has a net worth of over $2 billion and is famous for creating the largest online mall in Japan, known as Zozotown. With his profits, he has already spent millions on priceless art, which he plans to showcase in his own museum. But he doesn't want to make a name for himself only with his eye for art and fashion. He also wants to be one of the first private citizens to go to the moon. How he plans to get there is with the Big Falcon rocket manufactured by SpaceX. SpaceX has so far designed 3 rockets, Falcon 1 which launched in 2006, Falcon 9 which launched in 2010, and Falcon Heavy which launched in 2018. What has set these apart from the competition is the fact that they're cheaper than other models and in the case of Falcon Heavy can carry twice as much for a fraction of the cost. SpaceX created the Dragon spacecraft as well, with room for 7 astronauts on board. This was launched successfully on March 2nd using the Falcon 9 rocket. While unmanned, a mannequin named Ripley was on board, fitted with sensors to measure the impact of space throughout the trip. Its launch was a necessary step to prove travel on SpaceX's innovative machinery is safe for humans before manned travel can begin. Only then, and likely after a few additional such tests, can Big Falcon rocket, the one Maezawa will use on his 2023 trip, be given the green light for its journey. The behemoth is 35 stories tall, and while similar in function to Falcon 9, is capable of propelling a spacecraft carrying as many as dozens into space. The anticipated trip to the moon is just a starting point for the rocket and the company. Once SpaceX has proven it can successfully take humans there and back, it wants to do much, much more. The ultimate goal is to expand to the extent that the company transports people to other planets to live. In fact, according to its creator Elon Musk, who was also the co-founder of PayPal, an investor and CEO of car manufacturer Tesla, his motivation in first forming the company was to find an out for humanity when, not if, it is to survive. He believes in the case of a nuclear catastrophe, a colony on Mars may be the only hope for mankind. He has set his sights on Mars as a more hospitable location for human life than the moon. By building a colony there, Musk believes that come what may, there's a chance that Earth can later be repopulated. Despite the accusations of many, Musk says that Mars isn't intended to be any type of escape for just the wealthy. The 1 million he hopes to take there will have to brave dangers, he claims, many as yet unknown. In fact, there's a good likelihood that several among the first inhabitants won't survive, while those who do will revel in the excitement of making it. It will also be far from a leisurely experience, at least at first. Settlers will be responsible for helping develop its infrastructure and making prolonged life on its surface even possible. He compares it to settling Antarctica. Those who will go will be the ones whose desire for a thrill will exceed the fear of danger, not simply the rich, many of whom will enjoy a life of cushy comfort on their home planet. He does have a point that Mars is quite different from Earth, with a unique set of obstacles to overcome. It is smaller with less gravity and a thinner atmosphere that is almost entirely carbon dioxide. Without Earth's magnetic field, harmful levels of radiation are not deflected from its surface. It's also very cold and average temperatures are minus 81 degrees Fahrenheit. Days are longer and years last 687 days. It would take some adjusting to thrive on Mars, and without the use of assistive technology it would not be possible. Then of course there are the dangers of the trip over as well. To enter and exit Earth's atmosphere means exposure to extreme changes in gravity as well as millions of pounds of thrust at thousands of miles per hour. This is not exactly comfortable, and even seasoned astronauts have been known to develop a condition known as space motion sickness. Interestingly, it has been shown that those with medical conditions that are well controlled are not at risk during spaceflight. Psychological stress, on the other hand, is currently a challenge for private space travel companies. Questionnaires meant to screen potential passengers for their emotional fitness have proven far less than accurate. Many look to pre-flight training as a chance to familiarize passengers with what to expect and to avoid in-flight anxiety. After all, the flight will be unlike anything people have ever seen or experienced before, and it's quite incomparable to relatively comfortable and, for many, rather unremarkable travel via plane. Then there's the fact that even in ideal circumstances, the risk of dying on a spacecraft is 10,000 times greater than on a commercial aircraft. Having this knowledge in the back of their minds may prove more than a little unsettling for some. For legal reasons, each and every person who is taken to the moon or in time to Mars will be well versed on the risks of such a trip. However, as Maezawa has shown, despite its known dangers, many of the wealthy elite remain excited about boarding a spacecraft for the experience of a lifetime. And clearly, Musk believes his company and its mission will ultimately be quite successful. In fact, when society does eventually take hold on the Red Planet, Musk has gotten far enough along in his planning that he's considered the type of government that will rule its people. In his opinion, it will not be a democracy like current-day America, but more of a direct democracy where the majority wins. Ideally, legislation passed would be short and sweet, easier to repeal than implement. And when society needs a break from legal issues, Musk has joked that there will be plenty of bars in which it can grab a drink. Mars bars. He's also joked, rather eerily, of an alternative system in which he is the emperor of the planet. As one of the few in control of who gets there and when, as well as who can eventually make it back, this is a little less amusing. This is not the only thing he said that rubs people the wrong way. For example, despite his denials that his company will cater to only the rich, space travel is obviously not an option for the average person. As we mentioned, Yusaku Maezawa is a billionaire, and while Musk won't share just how much he spent to reserve his trip to space, he acknowledged that it was significant. Significant to a billionaire must be a hefty sum, and Maezawa not only bought his own seat, but also the 8 others available for the trip. He now gets to dictate just who will join him, and has decided it will be a combination of musicians, artists, and designers. In other words, Joe the plumber will not be on board. The trip to the moon will also be relatively short. According to NASA, the moon is 238,855 miles, or 384,400 kilometers away. This is the distance of 30 Earths. In contrast, Mars, with a distance that varies depending on just where it is in the orbit, is on average 140 million miles or 225 million kilometers away. That's obviously much further. Currently, if technology is not improved, many estimate that the much lengthier trip to Mars would cost $10 billion a person. However, Musk believes that reusable rockets and fitting 100 to 200 people per flight will significantly drive down the cost. His revised estimate, if these conditions are met, is something more like the average cost of a house, or $200,000. He thinks that those who start saving should be able to acquire this sum, or something close to it. And herein lies the problem in being a billionaire. While to him $200,000 is mere change, to others it represents the largest investment they'll ever make in their lives. Not to mention many who will live in a house do not actually own it, the bank does, and they never had $200,000 available as cash. And say the people do sell all that they own and move to Mars. Once this is done, they will effectively be stuck without the means to return. Although in a worst-case scenario, they may well not want to. Musk also has shared that perhaps in about a century going to Mars might be as little as 100,000 or even less. That means just 100 years to wait and see if a combination of conflict, natural disaster, or pollution that have chased the elite off the planet don't wipe out the poorer segment of society that will be left behind. Not to mention, many still won't be able to afford even this much. He's claimed that there's a 70% chance that he will go to Mars himself to live. In other words, he will be quite safe no matter Earth's circumstances. Which is why his argument that many of the richest might not want to populate Mars due to its harsh climate and lack of infrastructure is a relatively weak one as well. In interviews, Musk has made it perfectly clear that Mars will not be a vacation destination, but a means for self-preservation. If nuclear war on planet Earth seemed imminent or other situations occurred where life was threatened, one would think that the dangers of Mars would seem relatively insignificant in comparison. In these scenarios, it would literally be a difficult life or certain death scenario, which to most is not a difficult decision to make. The fact remains that Mars has half the diameter of Earth. Earth's population is projected to be around 9 billion by 2050. A colony of 1 million is a small fraction of this amount, and even if its space was utilized to its fullest, Mars simply cannot support that many people. So by the nature of the game, many will inevitably be left out. As this is the case, just who would the 1 million colony on Mars be? As we have discussed, it would definitely not be the poor, and likely not the middle class either. It would be the wealthy. Most of the companies attempting to privatize spaceflight to Mars are American, such as Musk's SpaceX and Amazon founder Jeff Bezos' Blue Origin. One would assume that many of those their spacecraft will carry with them would be American as well. While the wealthiest around the world might reserve a seat, entire impoverished nations would likely lack any representation at all. Unlike other modes of travel meant to benefit entire populations such as bikes, cars, buses, boats, trains, or planes, due to the unparalleled cost of its operation, space travel is inherently discriminatory. The plan to populate other planets will not improve the quality of life for most. It's limited on many fronts and will ultimately exclude a majority of the world, while accommodating only a select few. As the private for-profit industry works, these few will most likely be the ones who have the most money to offer and who will make the trip the most financially worthwhile. The date is July 22, 1969, and for the last 21 hours and 36 minutes, America and the world at large has been glued to its television sets, watching the incredible exploits of humanity's first steps on another world. The culmination of thousands of years of mankind's dreams and fantasies to reach past the bounds of Earth and touch the heavens, the American moon landing has ushered a new age of humanity and signaled the first brave steps of our civilization into the universe. Live updates on the mission have poured over televisions and radios around the world, and from time to time, glimpses of this historic mission have made their way back home to Earth. Now the world awaits the return of these bravest of men, ready to be welcomed back home not just as American heroes, but heroes for all the world. Suddenly though, television screens all over the globe cut from the non-stop news coverage of the historic moon landing to the White House, where a somber-looking President Nixon stares directly into the camera. With a faltering start, he clears his throat and begins to speak. Fate has ordained that men who went to the moon to explore in peace will stay on the moon to rest in peace. These brave men, Neil Armstrong and Edwin Aldrin, know that there's no hope for their recovery, but they also know that there is hope for mankind in their sacrifice. The president continues, finally nearing the end of his speech. In ancient days, men looked at the stars and saw their heroes in the constellations. In modern times, we do much the same, but our heroes are epic men of flesh and blood. Others will follow and surely find their way home. Man's search will not be denied, but these men were first, and they will remain the foremost in our hearts. For every human being who looks up at the moon in the nights to come will know that there is some corner of another world that is forever mankind. The screen cuts to the massive mission control room in NASA, the place where the hopes and dreams of every nation on Earth has rested for the last 6 days. With battery power failing on the lunar lander, communications with the men trapped on the moon are near an end. Finally, the two brave astronauts make their final goodbye to their loved ones and the world at large, imploring that the world should not mourn for them, but be inspired for their many accomplishments. The radio cuts out, The lander's gone dark. Trapped on the surface of the moon, the men will continue to have a few hours worth of oxygen, but will soon suffocate if they don't freeze to death first. On TV screens around the world, a priest appears live from inside the historic St. John's Episcopal Church in Washington, D.C. The father commends the souls of Neil Armstrong and Buzz Aldrin to the deepest of the deep, much as if he were conducting a burial at sea for fallen sailors. Then he finishes with the Lord's Prayer. The previous scenario was a very real possibility and a carefully crafted response should the historic Apollo 11 suffer some form of catastrophic failure and be unable to return to the Earth. Given the incredible number of unknowns involved in the mission, from the suitability of the lunar surface for a heavy lander to touch down on, to an unknown environmental hazard on the moon and their effects on men and equipment, NASA and the American government had made every preparation for the first manned moon landing to end in disaster. The real Apollo 11, of course, ended in a historic victory for all of mankind and signaled America's triumph over its Soviet rivals in the space race. Yet at many points throughout the mission, failure was only ever a heartbeat away. For example, when the lander undocked from the command module, the lander received a tiny bit of thrust from venting gases in the docking tunnel. While minor, in the weightless state of the spacecraft in orbit, this small amount of thrust actually placed the lander 4 nautical miles away from the point it was supposed to be when it was to begin its descent burn. In turn, this placed the planned landing site amidst a dangerous boulder field on the rim of a crater. Armstrong was famously forced to eyeball the landing and burned his fuel reserves dangerously low in doing so, but found a suitable landing spot nonetheless. What if the astronauts had died on the moon though? What if you died in space today? What would happen to your body, and how would NASA respond? If Armstrong and Aldrin had died on the moon, there were already plans in the US government to designate the site an official memorial. That meant that the site would be off limits to anybody else in the future. In essence, the astronauts' bodies would remain forever undisturbed inside their spacecraft for all eternity, or at least until the sun swallows the Earth and Moon up as it becomes a red giant one day. Even in some far-off future where the US or other nations had significant lunar presence, recovery of the bodies would be off limits. How much would be left of the bodies is debatable though. If the lunar module had not suffered any penetration of its hull, and the astronauts died, say, because of a power failure or a failure to ignite their ascent engine and return to the command module, then there would remain an atmosphere within the lunar module. This would also be true if the astronauts had simply stayed inside their spacesuits. In that case, bacteria would have begun to decompose the body much the same as they do here on Earth, using up the remaining oxygen in the atmosphere. There may not have been enough oxygen to keep humans alive, but there would have been enough for bacteria to thrive for a short while. When the oxygen ran out, however, bacterial respiration would switch to fermentation, and the process of decomposing would continue much as here on Earth, at least for a short while. The lunar lander was equipped with multiple layers of mylar insulation to help keep the heat of the sun from cooking the astronauts to death and destroying sensitive equipment, while other parts that wanted to receive warmth from the sun were coated in darker, more heat-absorbent materials. This ultimately would have seen the lunar lander very quickly go cold, and as the lander froze on the inside, so would the astronauts. How much decomposition would take place before all bacteria froze or suffocated to death is unknown, but the remains would likely remain very recognizable to future archaeologists who visited the site. What happens though if you die on a spacewalk? Let's say you're hanging out on the outside of the International Space Station and suddenly, through some error, you're blown clear of the ISS. With no hope of rescue, you suffocate within a few short hours. In this scenario, bacteria would begin to consume you much the same as on the moon scenario, as your suit will still retain an atmosphere for bacteria to thrive in. Eventually, the bacteria would die off, though you'd probably remain pretty warm for a long time, as your remains would remain exposed to sunlight. While space itself is cold, objects can be pretty warm thanks to the non-stop glare of the sun, and the lack of an atmosphere means that heat cannot be easily leached away the same way it does here on Earth. On a chilly winter day, your body's heat is steadily leached away by the atmosphere it's constantly in contact with. But in a vacuum, there's no medium to wick heat away from the body. This is why heat management is vitally important for all spacecraft and satellites. Eventually though, the blast of never-ending radiation from the sun and passing cosmic rays would begin to destroy the integrity of your spacesuit. Over the course of a few months to a few years, the spacesuit will eventually suffer a structural failure, and with your suit being full of your decomposing gases, it'll promptly explode as air rapidly expands due to the leak. You'll then litter your personal orbit with chunky bits of your leftover flesh and spacesuit both, like a gross overripe meat balloon that burst open. Space is risky business, and NASA has already planned on what to do about fatalities during one of its missions. During the age of the Space Shuttle, a crew fatality would be dealt with much in the same way that a current fatality would be handed aboard the International Space Station. The dead crew member would be very quickly placed inside a pressurized spacesuit and sealed inside, and then moved to the coldest part of the spacecraft for storage. This would be done to protect the rest of the crew and ship from contamination. And because dead bodies are, well, if you've ever been around anyone who's died, then you know it can be a messy affair, even if they die peacefully. In a zero-G environment, you really don't want to be dealing with the waste, stomach contents, and gases that will be voiding from the corpse. Aboard the Space Shuttle, the body would then simply be returned to Earth for a proper burial. Aboard the ISS, though, things would be a little trickier, as obviously the crew can't return whenever they feel like it. There, the body would likely be moved to an airlock so it could remain as cold as possible and preserved for a proper burial back home, and then could be placed inside one of the unmanned resupply craft that routinely visits the ISS. On a longer voyage though, say like a trip to Mars, NASA has to be prepared to handle crew fatalities as well, while astronauts are carefully selected to avoid any potential health issues that could cause a space fatality. Sometimes tragedy is simply unpredictable, and there are plenty of hazards out there in space waiting to claim lives. An extremely long-duration mission such as a trip to Mars is rife with possibilities for disaster, and fatalities must be planned for. In this situation, how to deal with a fatality would likely fall on the mission commander. Much like in the ISS, a fatality could simply be stored in a suit and then kept in an airlock, but mission constraints may not make that a feasible option. With such a long-duration mission, there's simply no way the crew could keep the body around indefinitely, both for practical reasons such as possible contamination from a suit failure, but also for morale reasons. In this event, simply jettisoning the body into space may be necessary. The spacecraft itself would likely be in an orbit, which would have it enter partially into the Martian atmosphere in order to help it slow down enough to get caught by Mars's gravity, instead of simply being slingshotted into orbit around the Sun again. This means that the body would likely burn up in the Martian atmosphere, being much lighter and smaller than the spacecraft itself. So if the astronauts wanted the body to have any chance of recovery by future space travelers, then it would have to be ejected with enough force to alter its trajectory and avoid burning up in Mars's atmosphere. As long as the spacecraft was far enough away from Mars, this could very easily be accomplished and require minimal thrust. The body would remain in orbit around the Sun, and in a century or two could be recoverable by future space archaeologists wishing to give it a proper burial. If you were to die on the surface of another planet though, then much like dying en route there, what happens to you would likely end up being the choice of the mission commander. If feasible, you may be stuffed into a suit and returned with the rest of the astronauts for burial at home. But likely, whatever foreign body you happen to be on at the time would end up being your permanent resting place. In order to avoid contaminating another planet with Earth life though, your body would need to be thoroughly cremated, something which may prove difficult to do on an early mission to Mars or another planet, but which would be critical. Someone, someday, is bound to die during a space mission, and what to do with their remains when they do is of vital importance, not just for the safety and comfort of the crew, but for the bereaved family members back home, and the world whose hopes and dreams rested in them. Hopefully we don't have to find out what NASA actually does with a dead crew member in space for a long time, but it's good to know that they're at least prepared to handle this eventuality.
In war, the high ground refers to the most strategic position available on a battlefield, and its occupation and exploitation gives the force occupying it major military advantages. With the dawn of the space age, it quickly became clear that the space around Earth was the ultimate high ground, and whoever conquered it first would put all other militaries at a severe disadvantage. So why hasn't it happened yet? That's what we'll find out today. In this episode of the Infographic Show, why can't we put weapons on space stations? The first and most obvious answer is a simple matter of physics. Newton's third law of motion states that for every action, there is an equal and opposite reaction. If you throw a ball, the ball pushes back on you, but the friction between your feet and the ground keeps you in place. If you were to try throwing a ball on roller skates though, the force of the ball pushing back on you would knock you backwards. Because space is a vacuum, there is no friction. So basic physics tells us that if you tried to shoot a rocket or fire a big enough gun from a space station, you would send that space station flying out of control. You would have to either counteract the force of the firing weapon with reaction control thrusters, or make a station massive enough that the force pushing back on the station is minimal. Though of course, you would still need to adjust your orbit after every shot to make sure you didn't accidentally deorbit your entire space station. With an average cost of putting objects or fuel into orbit resting at $1 million per pound, either option makes for a very, very expensive weapon. Guns are pretty much out of the question, but you could potentially design a missile that's gently released with a small puff of accelerant before its rocket motor ignites and carries it away, similar to how the International Space Station undocks visiting spacecraft. So why not do that? Well, basic physics is again the most obvious answer. A missile re-entering the Earth's atmosphere would experience the same extreme heating that a returned space capsule does. In order to protect the chemical warhead from accidentally blowing up, you would have to spend a lot of money on shielding materials to keep the warhead cool during re-entry. Ultimately, it's just not worth it. Conventional land, air, and sea-fired missiles are much cheaper and less risky. But there is one type of missile that would be worth the cost, risk, and difficulty of firing from orbit: a nuclear-tipped missile. The goal of a nuclear arsenal is not just to respond to a nuclear attack, but ideally to be able to destroy an enemy's own nuclear arsenal before they have a chance to retaliate. With nuclear weapons, speed is key. Yet even at a whopping 4 miles per second, an ICBM launched from Russia at the United States would still need about 41 minutes to reach the East Coast. If we put nuclear weapons in orbit though, that flight time would potentially shrink to mere minutes. The International Space Station, or ISS, orbits the Earth at 5 miles per second, making a complete orbit in just 92 minutes. If a nation were to build a constellation of just 6 nuclear-armed orbital stations at the same altitude as the ISS, 250 miles above Earth, there would always be one station loaded with nuclear weapons flying over enemy territory, and the next station with its nuclear payload would be a maximum of 15 minutes away. Most nuclear nations operate a nuclear launch and detection system made up of a small fleet of satellites that are constantly scanning the Earth for the telltale massive heat signature of an ICBM being fired. Once detected, other satellites and ground tracking stations use radar to track the ICBM. But a nuclear-tipped missile fired from orbit wouldn't need a big rocket motor. Instead, each missile could simply be released, use small RCS thrusters like those used on space capsules when docking to orient each missile to a different target, and then let gravity pull them down to Earth. Without a big, very hot rocket motor, an early warning and detection system would be useless, and outfitting a missile with radar-absorbent materials like those used on modern stealth aircraft would make radar tracking extremely difficult. Basically, a nation could launch a crippling sneak attack against another nation, decimating its nuclear stockpiles and ICBM launch complexes, and 15 minutes later have another salvo ready to fire as a new orbital station moves into position overhead. So why, especially during the heated rivalry of the Cold War, hasn't any nation done this? The official reason is the UN's Outer Space Treaty. Ratified on October 1st, 1967 by 107 countries, including China, the United States, and the Soviet Union, the treaty served as the basic legal framework upon which international space laws could be built upon. With the space race in full swing and humanity's imagination picturing a near future of space colonies and interplanetary travel, it became clear to the UN that space itself would soon have to be regulated much the same way we regulated the open seas with international maritime laws. Much more pressing, though, than a need for basic laws governing the use of space was the reality of potential conflict between two very hostile nuclear powers, the Soviet Union and the United States. MAD, or Mutual Assured Destruction, had for the moment maintained the peace and kept either nation from even flirting with the possibility of nuclear war, as each nation knew it could never survive a retaliatory strike. But with space technologies and capabilities rapidly evolving in both nations, the possibility of one nation putting nuclear weapons into space and thus circumventing the safeguards of the MAD doctrine became very real. Thus, while the Outer Space Treaty governs the use of space and prohibits nations from claiming sovereignty over any moon, planet, or anything in between, the main goal of the treaty was to ban the use of nuclear weapons in space and thus maintain the security of the MAD doctrine. This is the legal reason why no nation has ever tried to put weapons into space. But the Outer Space Treaty only governs weapons of mass destruction. And while, as we saw before, missiles or guns would do very little good in space, other weapons known as kinetic impactors would be extremely effective. Basically nothing more than a very large and very dense projectile, a kinetic impactor uses only its own mass, velocity, and kinetic energy to deliver incredible devastation. The impactor has no chemical explosive and relies on fundamental physics. Because force equals mass times acceleration, by dropping something very massive or dense from orbit and letting the force of gravity accelerate it to thousands of miles an hour as it falls, you could potentially deliver a destructive blast on par with a small, tactical nuclear weapon. In fact, the US military has used similar weapons before in both the Korean and Vietnam War. Known as lazy dog bombs, the projectiles were nothing more than 2-inch-long pieces of steel outfitted with fins. When dropped from an aircraft, the projectiles would reach 500 miles an hour and be capable of penetrating 9 inches of solid concrete. Not bad for having absolutely no explosive. So then why has no nation put kinetic impactor weapons in space? The reason, it turns out, is a matter of simple self-preservation. If any nation began such a program, every other nation on Earth would face 3 choices. A. Allow that nation to complete its orbital weapon system program and be at their mercy forever. Or B. Begin their own orbital weapon system program. Or C. Immediately go to war with that nation before they can complete building their orbital weapon system. In order to avoid all-out war, or risk creating an environment where even if it fields its own orbital weapons, a nation is still critically vulnerable to hostile orbital weapons it cannot possibly counter, the United States, Russia, and other spacefaring nations have, to date, simply refused to build these weapons. In the best case scenario, putting orbital weapons in space would simply force other nations to do the same, creating yet another mutually assured destruction scenario. Given how many close calls we've had already with our Earth-bound nuclear arsenals, it's ultimately best we simply stay away from putting any weapons in space, period.
Disclaimer: all of the stories featured in this episode of the Infographics Show come from actual military service members or other government officials, many of them vetted by independent researchers and local or national media outlets. It was late on a chilly February morning, 2007. At approximately 0230 hours, a security patrol stationed inside the nuclear weapon storage area of Nellis Air Force Base, otherwise known as Area 2, called into Central Security Control a sighting of what appeared to be vehicle headlights far outside the outer perimeter fence, a mile or two in the distance. This wasn't uncommon, as Area 2 was detached from Nellis Air Force Base, and everything from hikers to off-road enthusiasts would inadvertently stumble upon the little-known facility in the desert. Following standard procedure, the 2 outer security patrols, Oscars 1 and 2, were dispatched to assume overwatch positions on the reported headlights. Their job, as it often was in these dark desert nights, was to simply observe, and if the civilian vehicle approached too close to the facility perimeter, intercept it and have them turn around. As the 2 outer security patrols arrived atop the tall bluffs overlooking the reported sighting area, they spotted and confirmed what appeared to be 2 vehicle headlights approaching down the side of a nearby mountain. Inside of the nuclear weapons storage area, 2 additional patrols had moved close to the section of the fence the vehicle headlights were approaching, along with the site security supervisor, Security 1. A grand total of 11 Air Force security personnel were watching when suddenly the lights disappeared. Fearing that the oncoming off-road vehicle had turned off its headlights so as not to be tracked, Oscar 1 left its position on the bluffs and moved to an intercept position along the incoming vehicle's estimated avenue of approach. The site's security controller requested the assistance of a main base K9 unit, which had happened to be in the area, and the 2 patrols linked up, leaving their vehicles behind, moved out to the desert to set up an LPOP, or Listening Post Observation Post. The desert, though, was quiet. Despite the incoming vehicle having been within 2 miles of the fence line, there was no sound of a revving engine across the still, dark desert. Scans with both thermal imagers and night vision goggles revealed nothing. And then suddenly, the radio came to life. Patrols on the interior of the nuclear weapons depot began calling in lights on either side of the dismounted Oscar 1 and K9 patrol. From their vantage point atop the tall igloo-style weapon bunkers, they could see a series of lights appear in the 12 o'clock, 9 o'clock, and 3 o'clock of the dismounted patrolmen. Incredibly though, the 3 men and 1 dog on the ground could see nor hear anything. Then the site security supervisor came on the radio. "Oscar 1, be advised, the lights are moving on you." The 3 mysterious lights, seen only by interior patrols, suddenly rushed the dismounted patrolman. The senior patrol leader ordered his partner and the K9 patrolman to lock and load. With lights approaching their position on the desert floor at high speed, he was taking no chances. As far as he was concerned, the mysterious and now aggressive behavior of the lights indicated hostile intent. What happened next depends on which side of the fence line you happen to have been on. For the 3 patrolmen and 1 dog on the outside of the fence line, nothing happened. The 3 men held their breath, M4s at the ready, and nervously scanned the desert with thermals and night vision, but spotted nothing. They even checked with the dog, who was trained to indicate if it sensed danger, and yet nothing. After a few minutes, the patrol leader called back in over the radio to ask for an update on the lights, but received nothing but static. Trying a second and then third radio, the exterior patrols got no reply and slowly walked back to their vehicles to attempt to make contact with the interior patrols again. On the inside of the fence, though, at least 24 security forces patrolmen, including the Master Sergeant Security Supervisor, had seen the lights converge on the location of the dismounted patrol patrol and then simply disappear. Even more incredibly though, when the exterior patrolmen finally made contact with the interior patrols, they were told they'd been out of contact for 20 minutes. Yet each man involved in the incident on the outside of the fence line swore that only 3 or 4 minutes had passed for them. Where had the other 15 minutes of time, all spent without radio contact, gone? Things would only get weirder, though, before they got any better. This incident would prove to be only the opening act to some of the strangest events ever reported by US military personnel. And we can tell you about it in first person because at the infographic show, we got a chance to sit down with one of the security forces patrolmen involved in these incidents. After the exterior light show incident, things started to get weird. I mean, there had always been weird things out in Area 2. We had everything from ghost stories to weird animal sightings. I'd probably think it was all BS or just tricks the dark plays on you, except a lot of this stuff was seen by numerous people at the same time, or with the help of pretty advanced night vision and thermal imaging devices. What started happening after the lights incident, though, took the cherry in weird and outright dangerous. Within a week of the incident, one of the daytime exterior patrols ran across the corpse of a donkey, which wasn't that weird since there was no civilization around us and animals sometimes wandered out there. What was weird, though, was that this donkey had no head. It was cleanly cut off, and there was some crusted blood around the neck, but there was no blood anywhere around the body on the ground. We ended up shrugging it off, figuring that somebody had butchered the animal, just dumped it in the desert, completely unaware of how close they got to our facility in doing so. But then, just a few days later, another donkey corpse was found, and this one was missing its head and all 4 of its legs. Again, no vehicle tracks, no blood on the ground, just a decapitated legless donkey. The very next day after that, a third donkey was discovered by an exterior patrol, this time at night. This donkey was also missing its head and legs, but it had its stomach cut open with one clean incision, and the entire contents of the body cavity were gone. Once more, there was no blood on the desert floor and no vehicle tracks. We forgot about the donkeys after a while, and even though people kept reporting strange lights, nothing too dramatic happened until about 6 months later. What happened next took the cake. It was almost a full-blown national nuclear security incident. We used to practice assaulting our own storage facilities just in case bad guys got in and tried to steal a nuke, or just barricaded themselves so they could set off a nuke in place and irradiate large swaths of Nevada. One of those nights we underwent our usual exercise scenario, involving a response by multiple patrols and an assault into our designated training structure. All in all, somewhere around 17 to 18 people were involved. Most of the patrols were at the assault training structure, but we kept the patrol armed with an M249 machine gun on overwatch just to keep an eye on the desert behind us. Now, Area 2, the nuclear weapons storage depot, was huge, several square miles, so there was lots of empty desert inside the fence perimeter. As we were lining up to assault the training structure, we suddenly got a call over the radio from our overwatch patrol located on a hill about a quarter mile from us. The patrol said, "Hey, you got 2 figures lying prone in the desert behind you." We assumed this was part of the training exercise, so our on-scene commander redeployed a small element to secure our rear as the rest of the response force prepared to assault. However, our flight leader, or security supervisor, immediately came running up to us and told us to lock and load. He then called over the radio and told Central Security Control to terminate the exercise. Then he turned to look at us and said, "I didn't put anyone out in the desert. Whoever's out there is not us." Now, our security supervisor was in charge of running the exercises, and he would task random people with playing the bad guys. So when he told us that he hadn't put anyone out there, our blood ran cold. This was about as high a security area as you can get in the US military, home to dozens of nuclear weapons. Anyone who had somehow penetrated our security was not here to have a friendly chat. We immediately returned our magazines to our weapons and charged them, switching safeties off. Our Overwatch patrol had good eyes on the figures. One of the guys on that patrol was using a sensitive thermal camera, and the other was using night vision. That's the standard procedure for us since it gives you 2 vision modes to ID a target. According to them, the figures seemed to be laying on their bellies, watching us from about 100 meters behind, hiding behind a small berm. The desert out there was pitch black, so we got into a long line and formed a sweeping element. 2 heavy gunners on Humvees watched our backs and got ready to light up anything that turned hostile as we started our sweep in the desert. As we approached, our Overwatch patrol warned us that the figures were crawling into new positions. They were actually reacting to our movements and trying to remain hidden. According to the 2 guys who could see them over night vision and the thermal unit, the figures appeared frantic, as if panicking at having been discovered observing us. Yet they never stood up and stayed low on the ground on their bellies. For us, on the sweeping element, we couldn't see a thing, despite also using our own night vision goggles. However, the desert was thick with brush, so staying unseen would have been pretty easy for anyone laying low. We kept on moving forward, weapons at the ready, as our Overwatch patrol stayed in constant contact with us, letting us know what the figures were doing. Then, as we got within 25 meters, they just vanished. According to the Overwatch Patrol, the two figures were there one moment and then completely disappeared the next. No flash of light, no sound, nothing, just disappeared. We rushed forward to the last known location and swept the area, finding nothing. Although one of our guys had brought his handheld thermal imager and was actually able to pick up traces of warmth on the desert floor. Somebody or something had in fact been laying on that floor, long enough to heat it up, watching us as we practice our assault techniques. That incident might have been bone-chilling to hear about, definitely to have lived through, but it was far from the only incident involving possible UFOs or even aliens and nuclear weapons. Throughout the Cold War, the United States and even the Soviet Union had several extremely high-profile incidents involving nuclear weapons and UFOs, and these incidents have been reported by individuals with extremely high levels of credibility. In 1977, unidentified flying objects not only proved that they could intrude on U.S. airspace unimpeded, but that they might even have full control over our nuclear weapons. As told by United States Air Force Technical Sergeant Thomas E. Johnson, who was a flight security supervisor at the time, one night a security alert team was dispatched in response to strange lights low in the sky. At the time, Johnson was stationed at a North Dakota missile field, home to dozens of Minuteman intercontinental ballistic missiles, housed in underground silos, ready to fire on the Soviet Union at a moment's notice. As the team neared the reported area, they spotted lights in the sky ahead of them, varying in color. The lights would zoom from one location to another at impossible speeds, or other times would simply blink out in one location and blink in at another location. The security team leader said that he couldn't tell if they were multiple objects or just one incredibly fast object. Prior to the incident, the security personnel had been briefed by Air Force Office of Special Investigation agents that unknown helicopters had been reported at other Strategic Air Command bases. The Office of Special Investigation, or OSI, is like the Air Force's FBI, and the special briefings indicated that something very peculiar was going on at other U.S. Air Force bases. Yet that night, the object, or objects, didn't move like helicopters and made no sound. What they did do, though, was far more terrifying. Directly under the lights, the missile launch officers responsible for launching the Minutemen in case of war reported that they lost control over some of the 10 missiles they were in charge of. One of the launch officers later said that they couldn't communicate with the missiles, and if they had needed to launch, they would have been unable to. Incredibly, though, this type of incident would be repeated numerous times throughout the Cold War, and sometimes the actual targeting codes programmed into each missile would be altered or completely erased. Each of these occurrences always happened in conjunction with sightings of UFOs. Are UFOs monitoring our nuclear weapon sites? Is it a coincidence that every major nuclear weapon or production facility in the United States has a long history of UFO sightings? For a growing number of people, the UFO interest in our nuclear weapons is very real, and the case was only strengthened when, after the fall of the Soviet Union, former Soviet military and government officials revealed that their nuclear sites had also been host to UFO incidents. As climate change, scarce resources, and ever-advancing military technologies push the boundaries of humans toward deadlier and protracted conflicts, they look to other domains to gain a competitive advantage. With the world devastated by years of war and depleted of most of its natural resources, the global powers have turned space into its final battlefront. While these battles have not reached the point of firing lasers and other nifty space gadgets, like from an unnamed popular science fiction franchise, at this point in the future, due in no small part to Dogecoin billionaires, outfitting large armies of space soldiers has become possible. While there are many possibilities for this war to be fought in space, let's look at the first and most likely battlefield: the Moon. However, before we can even begin to see how this battle would play out, we first need to tackle the major question of if a gun can even be fired in space. When you pull the trigger of any gun, a firing pin strikes the primer that ignites the powder inside the cartridge. These expanding gases force the bullet out of its casing and propel it down the barrel. While there are quite literally hundreds of different powder combinations used throughout the centuries, one of the basic physics principles that remains constant through is the ability of the powders to combust. For that to happen, there must be air. Now, I know what you're thinking. There's no air in space, so you cannot fire a gun in a vacuum. But you see, if you thought that, you would be sorely mistaken. Inside each cartridge, you would find that the tiny amount of oxygen contained in each airtight and self-contained cartridge would still allow the gun to be fired. However, once you do fire that gun in space, that's where the otherworldly physics start to take place. Firstly, no matter where you fire a gun in space, you would not hear it, since there is no medium like air or water for sound to travel. However, you would still hear a very small, yet very altered sound due to the small vibrations firing the gun would have in your eardrum. When other people shoot a gun, because the sound vibrations cannot travel, you would not hear them, so if you forgot to bring that hearing protection with you on your spaceship, don't fear, since it would not make a difference anyway. Once the bullet leaves the barrel of the gun, gravity starts to take effect immediately. That's why when you fire a bullet, it will eventually drop to the ground. However, on the moon, gravity is 1/6 the strength of the gravity on Earth, and this would make for some very interesting dynamics. Taking a look at 3 of the most common military cartridges, one can see how the ranges at which the firefights can take place in space become exponentially increased. The standard issue pistol round for the US is 9mm, the standard rifle round is the 5.56mm, and the standard machine gun round is the 7.62mm cartridge. These rounds will travel a maximum of 1,900, 3,400, and 4,500 yards respectively. While their effective ranges are much shorter than these are the maximum ranges that when fired on a completely flat plane, gravity will eventually pull them down to the ground. Because the moon's gravity is 1/6 the strength of the gravity on Earth, that means you could multiply these distances by a factor of almost 2.5 times greater. So that means for a 9mm pistol, a space cadet could fire a 9mm bullet almost 4,700 yards, snipe at an enemy with his rifle at almost 8,300 yards, and suppress their positions with machine gun fire at 11,000 yards. Surely, these numbers are all theoretical since the military, at least publicly, has never tested its weapons in space. But if we're gonna go off the straight math, then it should work out this way. Of course, these numbers are just maximum ranges and do not factor in things like the ability to aim or the fact that the visible horizon for the human eye is around 11 nautical miles or about 22,000 yards, so shooting at a target over the horizon would be impractical for the average space soldier. Or would it be? You see, space does some weird things, and one of those is the pull of a gravitational field. Unlike on Earth, where the atmosphere is tens of thousands of meters up, if you're already in space or on an astral body with a limited atmosphere like the moon, or a very strong atmosphere like, say, Jupiter, then bullets can easily get sucked into these atmospheres. As one scientist described it, if you want to shoot yourself on the moon, you would simply need to stand on a mountain at least 1,600 meters up, then fire straight ahead. Now granted, the bullet would have to not impact any other mountain or debris by doing this, and the bullet could eventually circumnavigate the moon and come back to hit its hapless shooter. Eventually. If you fired the gun while in the void of space, it also has some weird physics that would go on. One of those would be its ability to keep moving forever, at least sort of. You see, as discussed previously, space being a vacuum, if there were no forces such as gravity or wind or weather that could impact a bullet's path and sap its energy, it would go on forever. In an ideal scenario, this would be the case. However, the likelihood of your bullet traveling forever in the cosmos with no other forces acting on it would be next to nothing due to all the planetary bodies acting on it. Going back to our earlier example of firing a gun at a planet, if during your lunar firefight you happen to miss your target and the bullet eventually makes its way towards, say, Jupiter, you could count on its strong gravitational pull to suck in your bullet. At about 3 times the strength of Earth's gravitational pull, you could expect that even at distances up to tens of thousands of meters away, the bullet would feel the effect of its gravity and eventually get sucked into orbit. Here, after getting trapped in orbit, the bullet could expect to travel at speeds of more than 17,000 miles per hour. And that's because the speed of objects in orbit is dependent upon their mass, gravity, and altitude, among a few other factors. While this would change from planet to planet, one would see the velocities of these bullets increase in magnitudes of 10 or more when placed in such scenarios. Another interesting aspect of firing guns in space is just how hot or cold they would be when impacting a target. On Earth, heat is transferred through a variety of radiation, convection, and conduction, which gives bullets, though hot, a more graduated temperature to its environment than in space. In space, heat only exists as radiation. So, if your bullet travels through, say, a patch of solar wind, it would instantly be melted, since the melting point of lead is around 320 degrees Celsius, while solar wind can reach temperatures of 1,000,000 degrees Celsius. However, all of these data points and figures revolve around firearms that are currently used on Earth, that are repurposed for space use. After all, if the human race were ever to fight a war in space, then it's probably safe to assume that the gun designs would also have to be upgraded. But what exactly would the ideal gun in space look like and be made out of to operate in such a harsh environment? First of all, that space assault rifle or pistol with wooden grips would probably be best left back at home. The obvious reason for this is that you should not bring highly flammable things into space due to the intense amount of heat that can be present. A material like wood would instantly catch fire if exposed to such extreme temperatures. Additionally, the water inside the wood would expand and evaporate inside a vacuum. What that means for our hapless space warriors that potentially in the middle of the action their gun could literally start falling apart, with the screws and anything else banding the stock to the gun coming apart. But what about the material that makes up the gun itself? Though many people might suggest tungsten as it has the highest melting point of any naturally occurring metal, yet is still malleable enough to be bent into shape, you might be mistaken. Rhenium is probably the best metal to make guns out of that would fire in space, for a few reasons. Firstly, it is still the second highest heat-resistant metal known to humankind. It also has strong electrical resistance properties in space, which is great since everything that goes into space has to be able to dissipate electrostatic charges that are everywhere up there. It's commonly used in the construction of aircraft, so it already has a good track record of good performance in harsh environments. Though people might point out that tungsten also has been used in a number of high-speed and highly successful jet aircraft programs in both the US and Russia and everywhere, they would be correct. However, though tungsten does have a slight edge of rhenium in melting point, the metal still beats it out in areas of ductility, electrical resistance, and creep resistance. Despite these advantages, rhenium is usually combined with tungsten to make an alloy to get the best properties of both, and it is this combination that might actually make the best material to manufacture firearms out of for space combat. But what about the bullets that are fired? After all, these bullets would have to survive their flight to their target through potentially much more extreme temperatures and conditions due to the increased distances that space combat can occur at. The answer to this problem might actually be an experimental alloy that was designed in 2015 that to this date has the highest melting point of any experimental or natural substance discovered so far. The alloy that was created was a combination of three elements: hafnium, tantalum, and carbon. The resulting concoction allowed for a blistering melting point of about 7,500 degrees Fahrenheit, or about 2/3 the surface temperature of the Sun. Such a metal would be perfect to use for space combat since they can handle almost everything space could throw at them, save for maybe solar wind and a black hole. Though this experimental alloy is still being developed at the University of California, there's real hope that it could be used in military applications in the future since a good portion of the funding for this research has come from the US Navy. Despite this influx of cash from Uncle Sam, the last report from 2015 was that scientists were only able to make 100 grams of the material, so it's unlikely such bullets would be available anytime soon. Overall, while firing guns in space might seem like a commander's dream with the increased ranges and zero noise, when one factors in all the harsh realities of space, firing guns might not be as simple as one might think. 73 seconds after launch, the Challenger space shuttle rises higher and higher towards space. Its iconic white solid rocket boosters roar as flames spew out of the back of them. The flight crew has continued to communicate with launch control since liftoff. No one knows that anything is wrong and that in the next second, tragedy will strike. A fire rages along the side of the right booster as fuel escapes due to a compromised seal. In moments, the supporting struts connecting the rockets to the orange external fuel tank will experience a catastrophic failure. The booster will slam into the tank, rocket fuel will ignite, and there will be a massive explosion. April 4th, 1983. T-minus 2 years and 9 months until the Challenger disaster. All systems go, prepare for liftoff. Mission Control says over the intercom to the Challenger flight crew, this will be the space shuttle's maiden voyage. The boosters ignite, and the 184-foot, 4.5 million pound space shuttle thrusts towards space. The first mission was a success, and the Challenger space shuttle will end up flying 6 more missions that year. The shuttle is reliable, but every time it launches into space and lands after re-entry, a toll is taken on the spacecraft. Constant repairs need to be made while old components are swapped out for new ones. Engineers who work on the shuttle day in and day out warn NASA that the stresses that constant missions to space place on the space shuttle may lead to tragedy in the future. July 19, 1985, T-minus 6 months until the Challenger disaster. We're pleased to inform you that you've been selected to become the first teacher to go to space. Krista McAuliffe can't believe the words she's just read. Several months ago, she submitted her application to the NASA Teacher in Space project along with 11,000 other educators. Never in her wildest dreams did she believe she would be chosen. However, this letter confirms that she will in fact be going to space and that she will be lucky enough to share this incredible experience with students across the country when she gets back. McAuliffe teaches at Concord High School in New Hampshire. When she tells her colleagues the news, they are elated. Her family, friends, and students are all extremely happy for her. As a part of the Teacher in Space project, she will conduct 2 lessons from orbit and embark on a lecture series across the United States to share her experience with students. This will be done to highlight the importance of teachers in the country and hopefully inspire students to pursue careers in technology and science. Over the next several months, McAuliffe joins her fellow crewmates at Johnson Space Center in Houston, Texas, where they train and prepare for their coming mission. Francis R. Scobie will be the commander of the spacecraft. In April of 1984, he piloted Challenger mission STS-41C, which deployed a new satellite and repaired a damaged satellite before returning to Earth. Since then, he's been an instructor pilot for the Shuttle 747 carrier aircraft. This will be his first space command, and he couldn't be more excited. Piloting the mission will be Michael J. Smith. He's flown 28 different types of civilian and military aircraft and logged 4,867 hours of flight time. Judith A. Resnick will be one of the mission specialists on board. Resnick had become part of Astronaut Group 8, which was the first to include women on the team. She's developed a variety of software and procedures that are utilized throughout NASA. She's been to space before aboard the STS-41D mission in August 1984. This was the very first mission of the Space Shuttle Discovery. 2 other mission specialists are a part of the Challenger crew as well. Ronald E. McNair flew aboard Challenger in February 1984 during mission STS-41B. It was on this mission that he became the second African American to fly into space. Ellison S. Onizuka was the first Asian American and the first person of Japanese origin to reach space during his time aboard the Space Shuttle Discovery during STS-51C. The final crew member aboard the upcoming Challenger launch, designated STS-51L, is Gregory B. Jarvis. He's the payload specialist. This will be his first time in space, although he's been slated to fly aboard a different shuttle in April of 1985, but his spot was given to U.S. Senator Jake Garn instead. Then a similar situation happened again in early January 1986 when U.S. Representative Bill Nelson took his place aboard another space shuttle. Now Jarvis finally has the opportunity to reach space where he can put his astronaut training to good use. But like every other member of the crew, he will never actually make it beyond Earth's atmosphere. January 22, 1986, T-minus 6 days until the Challenger disaster. The Challenger crew eagerly awaits confirmation of whether their mission is a go or not. A high-ranking NASA officer enters the room with a frown on his face. "Sorry about this, crew, but we're gonna have to delay your mission until 61C gets back. Their assignment ran into delays, and their shuttle isn't due to land until tomorrow." The Challenger crew looks at one another in dismay. They're eager to get going. Every mission to space is special, and even for veteran astronauts, it's what they dream about doing every night. It's as if the stars are beckoning them to reach for the unknown. January 27, 1986. T-minus 1 day until the Challenger disaster. Challenger mission STS-51L is planned to have an early morning liftoff the following day. The astronauts toss and turn in their beds in anticipation. A chill sweeps across Florida as if foreshadowing the ominous events that'll happen in the coming hours. The launch pad becomes covered in thick ice. The metals that make up the space shuttle and boosters contract slightly with the cold. As engineers check the spacecraft over and over again to make sure it's in an acceptable condition for launch, a disturbing realization surfaces. "Sir, I want to reiterate that I am concerned about the reliability of the seals in the rockets," an engineer explains to his supervisor. For over 2 years, the engineers and technicians that work in the shuttle program have warned that the space shuttles are being overused. The crafts are sturdy and well made, but every machine has its breaking point, and it feels as if after dozens of flights, it's only a matter of time before something tragic happens. The NASA official acknowledges the engineers' concern, but does nothing more. The launch will commence as scheduled, regardless of the warnings voiced by the men and women working directly with the spacecraft. January 28, 1986, 9 a.m. T-minus 2 hours and 38 minutes until the Challenger disaster. The sun is rising higher and higher over the Atlantic Ocean. A crowd gathers around Cape Canaveral to watch the launch at Kennedy Space Center scheduled for later that morning. There are members of the press, local residents, and people who have traveled from around the world to watch the launch. Many are there to witness the historic event of the first teacher to go to space. Excitement and anticipation fill the air. This will be the 25th Space Shuttle launch and the 10th Challenger mission. All other flights have been successful, so there's no reason to suspect today should be any different. The astronauts don their suits and proceed to their launch vehicle. They are greeted by cheers as they step off their transport and proceed toward the elevator that will carry them to the cockpit of the Challenger. Mission Control in Houston prepares to track and monitor the space shuttle's progress. Telemetry coming in from hundreds of sensors is recorded and double-checked to make sure that Challenger is ready. The astronauts strap in, and the shuttle door is sealed behind them. The cockpit is quiet except for the sounds of switches being engaged while Scobie and Smith check the systems on board. There's a sense of anxiousness, excitement, and pride as the 7-person crew prepares for launch. McAuliffe looks out the window directly ahead of her at the blue sky. Just beyond the atmosphere lies the edge of space. A bird flies past. McAuliffe smiles. Soon she'll be doing something that only a handful of people in all of history have done. She checks her safety harness and leans back in her seat, releasing a long sigh. Besides the crew, the shuttle also carries a tracking and data relay satellite designated TDRS-B. Also in the cargo bay is the Spartan Halley aircraft, which is designed to be released from Challenger to study Halley's comet for 2 days while the celestial object approaches the Sun. The small satellite will then be picked up by the Challenger crew and brought back to Earth so scientists can analyze the data it's collected. Tragically, no one and nothing aboard Challenger will survive to perform this series of tests. January 28, 1986, 11:38 a.m. T-minus 10 seconds until launch. Due to weather conditions, the launch has been delayed yet again. However, the atmosphere is beginning to cooperate. The sky clears up and the wind calms. Commander Scobie and Pilot Smith check their sensors and instruments one last time as they prepare for the rockets to fire. Mission Control reaches the end of its countdown. 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1. And liftoff. Moments before the engines ignite and the space shuttle rises, the solid rocket ignition command is sent. The boosters roar to life. The space shuttle and the earth around the launch pad begin to shake. The sound travels across the water and reaches the bystanders watching the space shuttle launch from miles away. Astronaut Judy Resnick is heard over the intercom. "All right," she yells. Challenger space shuttle achieves liftoff. After the rockets ignite, 8 25-inch long, 7-inch wide exploding bolts fire. The Challenger space shuttle is free to rise into the sky. The deafening boom of the engines, massive amounts of smoke, and intense heat roll across the launch pad. A quarter of a second after launch, sensors record the first vertical motion of Challenger as it begins its ascent. Unknown to anyone on board or at Mission Control, an abnormal black smoke is seeping out of the right solid rocket booster near the location of one of the O-ring joints. This is the first sign that something is about to go terribly wrong. 1 second after liftoff. "Here we go!" Pilot Michael Smith says over the intercom. As the space shuttle proceeds toward the heavens, the black smoke coming from the right rocket seems to be slowing down. 3 seconds after liftoff. Launch Commander Hugh Harris has just finished the countdown and pauses for a moment to watch. He announces on NASA Select Television, liftoff of the 25th Space Shuttle mission, and it has cleared the tower. The abnormal black smoke coming from the bottom of the solid rocket booster appears to have disappeared completely. 5 seconds after liftoff. All systems go. There are no anomalies detected by anyone at this point in the launch. The 3 liquid-fueled main engines on the back of the space shuttle are throttled up from 90% to 104% thrust. Everything is going according to plan. At Mission Control, Data Processing Systems Engineer A.F. Elgate confirms liftoff. There's a cheer in the room, then everyone immediately goes back to monitoring their stations. Suddenly, there's a data blackout from the space shuttle. No one panics. This is to be expected as the flames and structures around the launch complex interfere with the radio signals being sent to the antenna complex. But there is one piece of data that is slightly unnerving. I'm reading the internal pressure on the right side booster to be 11.8 pounds per square inch higher than normal, one of the technicians in Mission Control says. The rocket is still within acceptable parameters, but this initial data point will be used later on to identify when the Challenger space shuttle began to run into trouble. 8 seconds after liftoff. Once Challenger is in the open air, Pilot Smith begins a roll maneuver that puts the crew in a heads-down position so the top of the space shuttle is pointing toward the Earth and the bright orange external fuel tank is toward the sky. "Houston, Challenger, roll program," Commander Scobie says over the intercom. "Roger, roll Challenger," astronaut Dick Covey says from Mission Control. "Good roll, flight." Flight Dynamics Officer Brian Perry confirms from the control room. 19 seconds after liftoff. The Challenger space shuttle begins to shake. There's a sudden, violent thrust to the side. The crew grits their teeth as Michael Smith pulls on the flight stick slightly. With the help of the nav system, the space shuttle realigns itself and Challenger is back on course. "Looks like we got a lot of wind here today," says Smith over the intercom. Commander Scobie confirms the assessment. They begin throttling down the 3 main engines of the space shuttle to 94% thrust as planned at this point in the flight. 21 seconds after liftoff. Challenger's roll maneuver is completed and all systems confirm it is on the proper trajectory to reach orbit. Commander Scobie looks out the cockpit window, hoping to get a glimpse of the land below. "It's a little hard to see out my window here," he says. The engines continue to throttle down. 28 seconds after liftoff. "There's 10,000 feet and Mach 0.5, Smith says over the intercom. Challenger is now traveling at half the speed of sound and is 10,000 feet above the surface of the planet. It's at this point that the space shuttle begins reaching the region of maximum aerodynamic pressure. Mission Control confirms that engines are throttling down to 94% and remind the flight crew that they will be throttling down to 65% thrust in a few seconds. 35 seconds after liftoff, Smith begins to throttle down the engine some more. All data indicates that the shuttle's computer systems are making the proper adjustments to deal with the wind shear. 5 seconds later, Smith confirms that they have reached Mach 1. Scobie adds they're passing 19,000 feet in altitude. 45 seconds after liftoff, there's a bright flash slightly behind the space shuttle's right wing. Moments later, there's a second bright flash. 48 seconds after liftoff, a third flash appears downstream of Challenger's right wing. The crew can't see these ominous explosions, but a 70mm tracking camera captures them as it zooms in on the shuttle for a close-up view. Everyone who is viewing the footage is baffled at what they're witnessing. Suddenly, an orange ball of flames erupts from under the right wing. This fireball is coming from the right booster. The Challenger crew and Mission Control have no idea that anything is wrong, as the space shuttle's telemetry all reads nominal. The fireball from under the wing merges with the flames of the solid rocket boosters. 58 seconds after liftoff, Challenger accelerates past 1,539 miles per hour or 2,477 kilometers per hour. It has an altitude of 26,127 feet or 7,963.5 meters. Scobie gives the command to throttle the engines back as planned. Smith confirms the command. Mission Control confirms that the 3 engines of the space shuttle have all throttled down to 65% thrust. While this is happening, the tracking camera on the ground observes the first evidence that there is now something seriously wrong with the right solid rocket booster. An abnormal plume of smoke has begun pouring out of the rocket. The Challenger crew has no sensors in the cockpit that display the performance of the solid rocket boosters, and therefore are unaware that they are in serious danger. A second later, Challenger passes through the region of maximum aerodynamic pressure, which pushes against the space shuttle and its boosters with 720 pounds of pressure per square foot, or 7,750 pounds per square meter. The plume of smoke coming from the side of the booster intensifies. Inside the booster itself, an O-ring has disintegrated, the very same component that engineers at NASA were warning would fail if the space shuttle launches were not dialed back. The O-ring on the booster was meant to seal the joints between separate parts of the rocket and prevent the leaking of fluids and gases from one chamber to another. With the O-ring destroyed, fuel is making its way through the booster and igniting due to the intense heat of the flames. A continuous inferno is expelled from the right booster along the side furthest away from the space shuttle. The windows in the cockpit give Scobie and Smith limited visibility, and they're not able to see the fire from the shuttle. 60 seconds after liftoff. "Feel that mother go!" Smith says over the intercom. Another member of the crew is heard yelling with joy in the background. At that moment, Mission Control receives data that indicates the internal pressure in the right side solid rocket booster has begun to drop. It's not known at the time, but this severe drop in pressure is the result of the hole created by the ignited fuel spewing out the side of the rocket where the O-ring has failed. The flames pouring out of the side of the rocket begin to lick the fitting attachments that couple the back end of the booster to the external fuel tank on the underside of the space shuttle. This starts to degrade the integrity of the couplings. 62 seconds after liftoff, Challenger shudders once again from high wind speeds. The shuttle rolls slightly to compensate as it passes 35,000 feet and approaches Mach 1.5. The wind is worse than predicted and stronger than any of the previous 24 shuttle missions. However, it's still within acceptable limits, even if it puts slightly more stress on the shuttle. 64 seconds after liftoff, the flame in the right side booster changes shape suddenly as the heat from the fire melts through metal plating, and liquid hydrogen begins to fuel the fire. The glow on the outside of the booster intensifies. As the force of the raging fire builds up, it begins to move the engine nozzle in large arcs. This momentum begins to shift the space shuttle's course, which the computer then adjusts for. The right booster's thrust levels are thrown off due to the leaking fuel and fire burning on the side. However, the nav system manages to compensate. Tremors vibrate through the cockpit as the hydrogen fuel is ignited, but get lost in the turbulence experienced due to the massive acceleration and wind shear. 66 seconds after liftoff. "Throttle up, 3 at 104, Mission Control says over the comm. Houston and the Challenger flight crew are all still unaware of the fire coming out of the middle of the right booster, and other than a drop in pressure, there's no indication that there is a serious problem. The fire outside of the shuttle spread further. The flames creep toward the belly of the shuttle, where the external liquid hydrogen tank is located. The pressure inside the fuel tank suddenly begins to drop, indicating that an alarming amount of liquid hydrogen is leaking out. The The fuel tank gauge plummets inside the cockpit, but Smith and Scobie don't notice it as they're focused on throttling up the engines and preparing to disengage the boosters. Even if either crew member was looking at the fuel gauge, the rapid dropping of pressure happened so quickly that there was nothing they could have done. The fuel tank can only be disengaged when all other engines are turned off, and the shuttle is in a benign aerodynamic environment higher up in the atmosphere. If they had disengaged the fuel tank to get away from the leak at this stage, the Challenger would have been forced into the fuel tank and the still-burning solid rocket booster exhaust. 68 seconds after liftoff, the fire spewing from the side of the rocket connects to the exhaust plume. The liquid oxygen propellant being fed into the main engines of the space shuttle falls drastically. Smith continues to throttle up the engines to reach 104% thrust. 72 seconds after liftoff, the back end of the right booster is ripped away from the external fuel tank. The strut that had been securing it has been compromised and failed. The back end of the right booster is now moving up and down relative to the space shuttle and fuel tank. Another explosion, likely from the stress and leaking fuel, occurs higher up on the booster near Challenger's cabin. The flame near the top of the booster grows rapidly, creating an enormous fireball. The nozzles of the engines on the back of the space shuttle begin moving at a rate of 5 feet per second in order to compensate for the unhinged booster. The top of the right booster is still connected to the fuel tank, but the loose back end causes a burst of lateral acceleration that jerks the shuttle. The main engine pressure decreases. Engine nozzle motion rates are off the chart. Things are very, very bad. Challenger sends its final navigation update. 73 seconds after liftoff. "Uh-oh," Smith says. These will be the last words uttered over the comms by any of the Challenger crew. It's not clear what Smith is referring to, but it's likely that several sensors begin showing clear signs that something is wrong. The fuel tank and loose booster begin breaking apart. The shuttle jerks the opposite way it had moments before. The right booster is now producing 100,000 pounds of thrust less than the left booster. The unbalanced acceleration begins forcing the right booster up into the liquid oxygen section of the external fuel tank. Liquid hydrogen and oxygen begin leaking out of the external tank. A cloud of fuel accumulates outside. The right booster pushes further into the fuel tank and increases the amount of liquid oxygen being expelled. Milliseconds later, the inevitable happens. There's a bright flash of light located between the Challenger shuttle and the external fuel tank. The leaking fuel has been ignited. The fireball engulfs the space shuttle. There's a crackling sound over the intercom as ground transmitters search for a signal that is no longer there. Another explosion occurs near the front of the external fuel tank. This ignites the remainder of the fuel inside the front section of the tank, causing it to detonate. Challenger's engines redline and the computer initiates an emergency shutdown. Main engine 3 goes first, followed by number 1. The last telemetry signal from the space shuttle is sent while it is being torn apart. 74 seconds after liftoff, the radio signal from Challenger goes silent. Another explosion occurs near the space shuttle's nose. The cockpit with all 7 members of the crew is engulfed in flames as the rocket fuel in the forward reaction control system ignites. The debris of the destroyed shuttle continues traveling upward at Mach 1.92, or approximately twice the speed of sound. It reaches an altitude of 46,000 feet or 14,021 meters. Challenger's tail emerges from the fireball around the same moment that a wing can be seen. The fuselage and payload bay are torn apart by the rush of air forced in from the tail being ripped off, overpressurizing the payload bay and breaking it apart from the inside out. Wires and electrical cables flail behind the fuselage like tentacles. The satellites in the cargo bay are ejected into the air. The crew cabin arcs out of the flames and smoke. It seems to be intact, although there's a gaping hole where it used to be connected to the rest of the shuttle. Some of the crew may still be alive and awake, but when the Challenger is ripped apart, all of the air is sucked out of the cockpit, and a dramatic pressure drop results in everyone passing out. For this mission, the astronauts did not wear pressurized suits during liftoff. As they slump in their seats unconscious, oxygen deprivation settles in. Any crew member who is still alive will suffocate within the next few minutes. The 2 solid rocket boosters continue to fly upward at different angles, now free from the struts that connected them to the external fuel tank. 1 second after the Challenger space shuttle explodes. Mission Control does not yet know that the Challenger space shuttle has exploded. 1 minute 15 seconds, velocity 2,900 feet per second, altitude 9 nautical miles, downrange distance 7 nautical miles, says Stephen Nesbitt, the public affairs officer at Mission Control. 2 seconds after the Challenger space shuttle explodes. A parachute emerges from the carnage, giving people hope. But as the tracking camera focuses, it turns out to be the nose cap of the right solid rocket booster. Smoke and flaming debris arc outward from the blast. The rocket boosters continue to fly upward, leaving a corkscrew trail of smoke behind them. 15 seconds after the Challenger space shuttle explodes. Flight GC, we've had negative contact, loss of downlink, says the ground control engineer N.R. Talbot. It's at this point that Mission Control is aware something tragic has happened and is trying to figure out exactly what happened. They're informed that the Challenger space shuttle has been lost. 36 seconds after the Challenger space shuttle explodes, a self-destruct signal is sent to the rogue solid rocket boosters, triggering an emergency detonation. Both rockets explode in a plume of black smoke. Debris falls back toward the Earth. Without the weight of the space shuttle and the fuel tank, there was no telling how far the rockets would have gone before burning the last of their fuel. They needed to be detonated to eliminate the risk of them crashing back to Earth in a populated area rather than the desolate waters of the Atlantic Ocean. 1 minute and 31 seconds after the Challenger space shuttle explodes. Multiple sources have now confirmed that the Challenger STS-51L has been lost. Rescue efforts are launched. 2 minutes and 11 seconds after the Challenger space shuttle explodes. The TV tracking camera spots the first pieces of the space shuttle crashing into the ocean. 33 seconds later, the crew cabin slams into the waves of the Atlantic at approximately 200 miles per hour or 322 kilometers per hour, at a braking force 200 times that of normal gravity. The crew cabin disintegrates on impact and sinks 100 feet to the bottom of the ocean. For the next few minutes, debris continues to splash down into the ocean east of Patrick Air Force Base. A cloud of brown smoke lingers over the surface of the water as a result of the hydrazine rocket fuel that covered the wreckage as it entered the ocean. Mission Control pinpoints the crash site as being approximately 28.64 degrees north at 80.28 degrees west, 5 minutes after the Challenger space shuttle explodes. The broadcast on NASA television has been eerily quiet as everyone tries to take in what just happened. The camera view switches from the ocean back to the grandstand at the press site. Observers stand with their backs to the camera, looking up at the sky where a white cloud of smoke still lingers. White wisps of haze extend from the explosion site, like weeping willow vines indicating where burning debris fell from the sky. 8 minutes and 5 seconds after the Challenger space shuttle explodes. This is Mission Control, Houston. We are coordinating with recovery forces in the field. Range safety equipment, recovery vehicles intended for the recovery of the SRBs in the general area, says Stephen Nesbitt in a somber voice. The only thing left to do is go through the data, recover as much of the space shuttle as possible, and determine what caused the horrific accident that led to the loss of 7 people aboard the Challenger space shuttle. March 7, 1986, 1 month and 10 days after the Challenger space shuttle disaster. The USS Preserver bobs up and down in the dark waters of the Atlantic Ocean. A dive team has just been deployed to scout the hypothesized location of the Challenger cabin. The divers locate the wreckage that was in the front of the space shuttle and confirm that the bodies of the crew are still inside. The aftermath of the Challenger space shuttle disaster. All space shuttles are immediately grounded, and any upcoming launches are canceled, pending a full investigation of what happened to the Challenger. NASA and a group of men appointed by President Ronald Reagan, known as the Rogers Commission, began looking into the chain of events that led to the loss of the space shuttle and its crew. It's concluded that the space shuttles are being pushed too hard, and the concerns of engineers working on the crafts are being ignored or overlooked. What it came down to was that NASA had been trying to accomplish too much with too little funding. The investigation also determines that the 2 rubber O-rings which led to the fuel leak in the right booster and eventual catastrophic explosion of the external fuel tank were compromised by the severe cold from the night before the launch. Unfortunately, even if the crew had been aware of the problem at liftoff, there would have been no way for them to avoid the disastrous consequences. The space shuttle wouldn't have been able to survive a high-speed separation, even if it was attempted before the external fuel tank exploded. On June 6, the report is given to the President, who determines Marshall Space Flight Center in Huntsville, Alabama, Morton Thiokol Inc., and NASA as a whole are responsible for the Challenger disaster. Marshall Space Flight Center constructed the shuttle boosters, engines, and tank, while Morton Thiokol manufactured and built the booster motors. It's also uncovered during the investigation from several engineers who testify that they expressed concerns specifically about the O-rings and their seals to their supervisors for at least 2 years prior to the loss of the Challenger. The Rogers Commission recommends that communication between engineers and NASA management be tightened, quality control procedures be improved, and several more checkpoints be added to the Shuttle Safety Advisory Panel. On September 29, 1988, the Space Shuttle Discovery launches with 5 veteran astronauts on board. This is the first mission since the Challenger disaster. The Space Shuttle program lasts for 23 more years. On July 8, 2011, Atlantis launches from Cape Canaveral. It will be the 135th Space Shuttle mission. Atlantis lands on July 21, 2011, marking the official end of the Space Shuttle era. 2 space shuttles were lost during the 30 years that they were in use. On February 1, 2003, Space Shuttle Columbia disintegrated as it re-entered the atmosphere. And on January 28, 1986, Challenger exploded due to a faulty O-ring. Both crafts had a crew of 7, all of which were lost, and all of which were heroes.
It's a calm, clear night, and you're lounging on the grass, staring up at the twinkling stars, wondering about the vastness of space and the mysteries of the universe. As you stare in awe at the cosmos, your mind is filled with questions about the universe and our place in it. How many stars are there? How much of space can we even observe? Are we really alone in the universe? It may seem like we're well on our way to understanding the cosmos, but in reality, we've explored less than 0.1% of the entire known universe. And there are still countless mysterious space events that astronomers can't explain. Humans have been watching the skies for millennia, observing cosmic events and trying to interpret and predict their effects on the events of Earth. After centuries of stargazing, we now know more about space than our ancestors ever could have dreamed. We know that Earth is a planet in the solar system that orbits our sun. We know that our solar system exists in the Milky Way galaxy. And we know that there are countless other galaxies, stars, and planets in the universe. We know that stars can die in spectacular ways, and we know that our universe is constantly expanding. Perhaps more importantly though, we know how little we actually know about the universe, and we know that we will never know everything about the cosmos. As impressive as humanity's knowledge of the universe is, there are many more space mysteries than cosmic answers when it comes to our universe. Take, for example, the recent discovery of the Cow, a mysterious explosion in deep space first observed in 2018. Astronomers and hobbyists alike were mystified when they looked up into their telescopes on June 16th and saw an unusually bright glow in the sky that definitely hadn't been there the day before. Even seasoned astronomers thought this was super weird. At first, experts thought they were looking at a fairly common event somewhere in our galaxy. Perhaps a white dwarf, the burnt-out remains of a star that was consuming material from a nearby star, causing it to flare up. But once astronomers analyzed the Cow's light spectrum, they realized that the thing they were seeing was not in our galaxy at all. It was actually much farther, up to 200 million light-years away. A white dwarf would never be visible from that distance, and the object wasn't displaying the hallmark changes in brightness that we'd expect from a supernova. Experts were transfixed. The Cow didn't behave like any space events they were used to. It just appeared one day and continued to burn hot for nearly 3 whole weeks. The unusually long and steady duration of the light pointed to some sort of massive explosion deep in space. We just have no idea what caused it. Some think it was an unusual kind of supernova where the star's core collapsed inward after it exploded. Others think it was a tidal disruption event, a star being ripped apart by a black hole. But black holes big enough to tear apart a star are usually only found at the center of a galaxy, and the bright lights of the Cow were coming from the outer edge of the galaxy's spiral arm, leading some to theorize that a smaller black hole is responsible. But we're not sure if those kind of black holes even exist. Anna Ho, a researcher from the California Institute of Technology, finally decided to try observing the Cow using a sub-millimeter array, which sends short-frequency radio waves into space. This wouldn't normally work because the phenomenon we're trying to observe usually disappears before the radio waves can reach it, but the Cow's unusually long and bright existence gave the waves enough time to reach it, allowing researchers to monitor the event for several days before the signal dramatically dropped off. Based on this data, Anna theorized that the light we could see was the result of the shockwave from some unknown giant explosion traveling through a cloud of dust and gas, emitting light as the gas is heated. If you're surprised by the fact that scientists can't agree on an explanation for an event that we can clearly see with our own eyes, you may be wondering what else we don't know about space. Well, it turns out there's plenty we don't know. Take, for example, black holes. Common in both sci-fi and real scientific theories, you might think we have them all figured out, but it's actually shocking how little we know about black holes. Black holes are giant masses of cosmic quicksand that are formed when a giant star collapses and all of its mass implodes into a tiny area of such intense gravity that even light gets sucked in. Because no light can escape from a black hole, we can't see them with our own eyes. We only know they exist because we can observe how the stars and gases closest to them behave. The black hole's super strong gravitational force pulls any nearby objects toward it, When a star is close to a black hole, it also creates a type of high-energy light that can't be seen with the naked eye, but can be detected using special satellites and telescopes. The types of black holes caused by an imploding star are called stellar black holes, and they can be up to 20 times more massive than our Sun. Some black holes are as small as a single atom, but have the mass of a large mountain. At the center of each galaxy in the universe is a supermassive black hole, which scientists believe were created at the same time as the galaxy they're in. Sagittarius A is the name of the supermassive black hole at the center of our galaxy, the Milky Way, and it has a mass greater than 4 million of our suns. Before you start panicking about how Earth is slowly being sucked into the black hole at the center of our galaxy, let's move on to some other less stressful space mysteries. We talk a lot about all of the different stuff that makes up the universe, the planets and stars and solar systems and galaxies, but we don't often think about the absence of stuff in space. During the Big Bang, all of the matter in the visible universe that had been compressed into a single point began rapidly expanding outward. More than 13 billion years later, what started out as small variations in the density of matter have turned into huge empty voids in space. The largest one that we know of, the Great Void, is 1.5 billion light-years away from us and measures more than 1.3 billion light-years across. To be fair, these voids aren't totally empty. They are filled with dust, gas, and even dark matter, but the density of matter in a void is less than a tenth of the average for the rest of the universe, making them quite unusual. So what is this dark matter that's floating around in these space voids? With all the talk about dark matter and energy in recent years, it may seem like we're well on our way to understanding these dark forces, but much like black holes, we can't actually see dark matter or dark energy, and what little we do know about them is purely guesswork. We know that the universe has been expanding since the Big Bang, and for decades astronomers theorized that the rate of expansion was slowing over time due to the effects of gravity. However, all their theories went out the window in 1998 when the Hubble Space Telescope made a shocking discovery. By observing a very distant supernova, the Hubble proved that the universe had been expanding more slowly in the past than it was today, meaning that the expansion of space was actually speeding up, not slowing down. This discovery stumped the experts. No one was sure exactly why the expansion was accelerating. Perhaps it was a problem with Einstein's theory of gravity or the existence of some unknown energy fluid in space. Even though astronomers couldn't explain this phenomenon, they gave it a name: dark energy. We know that dark energy exists and how much of it there is by how it affects the universe's expansion. Scientists have estimated that up to 68% of the universe is made up of dark energy. Some experts also theorize that dark energy is evenly distributed through both space and time, meaning that as the universe expands, it creates more dark energy. Dark energy does not have its own local gravity, but instead has a repulsive effect on the universe as a whole, causing the expansion of the universe to accelerate. Scientists need much more and better data to make any headway in understanding dark energy. If dark energy makes up 68% of our universe, dark matter makes up another 27%. That means all of the so-called normal matter that we can see and observe even with our most sensitive equipment makes up only a measly 5% of the entire universe. That's a little bit unnerving to think about. Like dark energy, dark matter is invisible. It does not interact with electromagnetic forces. It doesn't absorb, reflect, or emit light. So the only way we know it exists is by observing the effects of its gravitational pull on other matter. If dark matter were created during a controlled particle collision at CERN's Large Hadron Collider, the dark matter would escape undetected by their equipment. But scientists could infer its existence by measuring the amount of missing energy after the collision. One of the most interesting theories about dark matter is the existence of a hidden valley, a parallel world made entirely of dark matter. If imagining an entire parallel world made of dark matter is making you uneasy, wait until you hear about the evil twins of outer space. Subatomic particles like protons, electrons, and neutrons all have an evil twin, antimatter. Antimatter particles have the same mass as normal particles, but the opposite electrical charge. As a result, antimatter destroys normal matter on contact. And that sounds terrifying, but don't worry, there's very little antimatter in the universe, and it can actually be harnessed for good. PET scanners work by creating anti-electrons and using the energy that's released when they're destroyed to create sophisticated images. Even more wild than evil twins is the theory of quantum entanglement. In quantum entanglement, two particles in completely different parts of the universe can actually be linked to one another and will mirror the state and behavior of their partner over great distances. At first, this seemed to break some pretty fundamental laws of physics, since they thought that the signals sent between particles would have to have traveled faster than the speed of light. But eventually, as scientists began to unravel the puzzle of quantum mechanics, they started to understand how this spooky action at a distance, as Einstein called it, actually works. It would take a whole other video to begin to explain quantum mechanics, but the basic idea is that unobserved particles exist in all states simultaneously, and takes on one state only when it's observed and measured. It's like that old riddle: if a tree falls in the forest and no one's around to hear it, does it make a sound? As you lay back on the grass and take in the marvel above you, there's still one space mystery tugging at your curiosity. Are we really alone in the universe? This is yet another mystery of space that continues to stump scientists. According to the Fermi paradox, the universe is so massively huge and so unimaginably old that all probability points to a high likelihood of extraterrestrial life. And yet, we have no evidence of life outside our own planet. Enrico Fermi, the Italian physicist credited with sparking this debate, theorized that any civilization with modest rocket technology could colonize an entire galaxy within the span of 10 million years, the blink of an eye in the timeline of our universe. It's entirely possible that life has existed outside of Earth, and that the lack of evidence is more of a problem of right place, wrong time than proof that we truly are alone. If you really want to have your mind blown as you gaze and wonder at the stars, consider the multiverse theory, the possibility that our universe is just one of many possible infinite universes. The fact that this is a valid theory currently being studied by renowned scientists just goes to show you how very little we really understand about the nature of the universe. As fascinating as space mysteries are, the lack of definitive answers can be frustrating. Your best bet is just to enjoy your time laying in the grass staring at the cosmos. And if you're lucky enough to see a shooting star, maybe you can wish for an answer to these space mysteries that astronomers can't explain. On April 29, 2019, the Parkes Radio Telescope in Australia was trained on our nearest galactic neighbor, Proxima Centauri, a small red dwarf roughly an eighth the size of our own Sun. Proxima Centauri nonetheless has been a candidate for Breakthrough Listen, a privately funded multi-million-dollar initiative to conclusively discover evidence of alien life by listening in on its transmissions. That's because out of a possible 3 planets in orbit around our closest galactic neighbor, just 4 light-years away, Proxima Centauri b sits comfortably in the habitable zone of its parent star. And on that fateful day in 2019, scientists may have recorded the first evidence of intelligent extraterrestrial life. Scanning Proxima Centauri for signs of solar flares, the Parkes Radio Telescope recorded something altogether different. Buried amidst the radio noise being blasted out by the red dwarf was something unique: a single narrowband transmission at a frequency of 982.02 MHz. What's more, the signal repeated a total of 5 different times. The signal was discovered by researchers working for the Breakthrough Listen initiative, a program aimed at discovering intelligent alien life funded by Russian billionaire Yuri Milner. Breakthrough Listen is SETI on steroids, with a survey that will eventually include over 1 million stars in our own galaxy, and will even include over 100 galaxies outside of our own. But because aliens might be trying to communicate in ways other than radio, Breakthrough Listen will also use extremely sensitive telescopes to look for laser signals amidst the light put out by millions of stars. Large, powerful lasers could put out concentrated light that a distant civilization would instantly recognize as being artificial, and has thus been proposed as one of several extremely likely ways civilizations might signal each other from across the galactic void. At a total cost of $100 million, and after almost 4 years of operation, Breakthrough Listen finally had compelling evidence of alien life. But this isn't the first time odd radio signals have been detected, so what makes BLC-1 so unique, and why is it potentially alien in origin? The first qualifier, and what immediately got the attention of researchers, is the narrowband nature of the signal. Natural cosmic phenomena almost always produces broadband signals, and as of yet only humans are known to use narrowband radio signals. This has raised the possibility that the signal is in fact human in origin. After all, the same sensitive telescopes being used to hunt for alien signals from stars thousands of light years away are sensitive enough to be affected by interference from the Earth or space directly around it. Sometimes, as in the case of one radio telescope facility, even a faulty microwave can cause false positives in the data. Yet if BLC-1 is in fact coming from a man-made source, and at this point the responsible assumption is that it's not alien in origin and just human interference, then it must be coming from a particularly perplexing source that astronomers have yet to pin down. That's because properties of the signal itself are extremely peculiar.
For starters, the signal may not even be from Proxima Centauri, as the signal originates from a 16-foot wide circle around Proxima Centauri in the sky. That's quite a lot of real estate. What is notable though is that when astronomers moved the telescope away from the signal and then back again hours later, a common technique to rule out Earth interference, the signal was still present. In fact, it would be detectable for 30-minute periods over several days. Keep in mind that astronomers who were operating the telescope at the time did not even know the signal was there. It was only discovered buried in the data a full year later. Had they known it was there, they could have made even better observations, which may have helped prove or disprove its alien origin. What's important is the signal did in fact repeat in the same relatively small patch of sky and for up to 30 minutes at a time. This means the only realistic explanation for Earth-based interference would be a satellite. Yet, for the signal to continue uninterrupted in such a small area of the sky would require a satellite to be in an extremely high and very slow-moving orbit. Otherwise, a normal satellite would simply move so fast, the signal would leave the telescope's narrow listening cone after only a few minutes. Now, this isn't the first time that astronomers have found an exciting signal from space only to discover later it was coming from an unregistered spy satellite. However, this satellite would have to be in an unrealistic orbit over the Earth that would seem to have little to no functionality for its operators. Even more damning is the fact that the signal does not modulate, meaning that there's no information in the signal. It's just a steady, clear tone, something that again would have no known value to human operators. Even more interesting is that the signal increased in frequency over time as it was observed, in the exact same way that a signal being broadcast from the surface of a planet or moon would do as the body it was stationed on slowly rotated in space. The only way this could be replicated in a man-made source would be if the object creating this transmission slowly increased its frequency for again an unknown reason. Detractors have pointed to the lack of information in the signal as making it unlikely to be alien in origin. And as we mentioned earlier, the signal does in fact not contain any information. It's simply a monotone broadcast that continues without interruption. However, there is one type of artificial radio signal that we humans use that matches the same properties of BLC-1 perfectly, and something that aliens would no doubt also be using: radar. Our own radar emissions have washed over several of our nearest galactic neighbors by now, so would it be any surprise if alien radio astronomers inadvertently blasted our own planet with their radar too? What would be perhaps entirely too coincidental, however, would be two intelligent species with similar levels of technology arising right next door to each other. But then again, the universe is so vast, the probability is almost certainly 100%. Roll the dice enough times and almost anything is possible, including two galactic neighbors blasting each other with their radar. With the answer to the greatest question mankind has ever asked on the line, are we alone? Science must tread very carefully and err on the side of caution. So for now, the reasonable assumption is that BLC-1 is simply some unknown form of man-made interference. However, BLC-1 is by far the strongest candidate ever discovered for alien life, beating out even the infamous WOW signal discovered in 1977. With several more years of listening to go and a plethora of new radio astronomy equipment being built now, humanity may soon have the answer to the ultimate question. And if we're really lucky, that answer may come from right next door, creating a very real possibility of one day meeting our alien neighbors face to face, and hopefully not having them eat our brains. The date is August 2018, and several hundred miles above the Earth, the Russian Soyuz spacecraft docks with the International Space Station. With the cancellation of the American Space Shuttle program and a failure by President Bush and Obama to streamline the acquisition of a new space vehicle, now Russia is the only agency in the world capable of reliably putting astronauts in space and bringing them home again. Every member nation of the International Space Station relies on Russia's Soyuz to ferry their astronauts to and from the ISS, and the cost isn't cheap. For Russia's Roscosmos space agency, though, the Soyuz has been an economic boon, earning them tens of millions of dollars per launch in seat fees. The Soyuz itself is a decades-old design hailing from the early Cold War, but still a very capable and safe space vehicle. Not just the final capsule that brings astronauts to the ISS and brings them home again, the Soyuz vehicle is actually the entire series of components and rockets that make up the total launch vehicle. Its safety record is unmatched, and to date, Russia's Soyuz space launch vehicle is the most reliable ever created. The only two deadly incidents involving a Soyuz in flight include a failure early in its service history that saw a parachute fail to open properly
killing the lone cosmonaut as the capsule impacted the Earth at high speed. The second incident remains the only fatalities in space, with 3 cosmonauts killed when a cabin vent valve accidentally opened after undocking from the Russian space station Salyut 1. It should be noted that both these accidents occurred early in the Soyuz's service history, and since then no fatalities have been suffered. Despite these accidents though, the Soyuz system has still seen less fatalities and accidents than the American Space Shuttle. Perhaps not surprising given that the system is relatively simple compared to the incredible complexity of the reusable shuttle. This simplicity is what makes operating the Soyuz so cheap and cost-effective for the cash-strapped Russian space agency Roscosmos though, and also makes the Soyuz a hardy and very reliable spacecraft. When the American Space Shuttle program ended, Soyuz was the only way to get astronauts to and from the ISS, today costing the US about $83 million per seat. Now, several alternatives to Soyuz are nearing flight readiness, such as SpaceX's Dragon capsule and Boeing's Starliner. Yet for the immediate future, mankind's only way to reach the stars lies with Russia and its Soyuz spacecraft. Yet in that fateful August of 2018, the crew of the ISS discovered that there was something very wrong with the space station. Atmospheric pressure was slowly but steadily dropping as the station vented precious oxygen into space. If nothing was done, the International Space Station would be left without any air and the crew would die. Immediately, the crew aboard the station began isolating compartments with airtight emergency doors, seeking to discover the source of the leak. Eventually, their hunt led them to the Soyuz capsule itself, docked to the station and the astronauts' ticket home. A deliberate and careful search of the spacecraft was then conducted, with every inch of it scoured in search of the offending leak. The astronauts soon discovered the cause, a 2mm hole on one of the capsule's walls, which perforated the outer skin of the craft and allowed the vacuum of space to suck air out. The hole was immediately sealed with a piece of special tape, and later a special epoxy meant to be used in emergencies was used to successfully seal it until the spacecraft returned to Earth. On the ground, both NASA, the ESA, and Roscosmos immediately began an investigation into the possible cause of the hole, and initially the theory that a micrometeorite impact had caused the hole was put forward. Micrometeorite impacts are not uncommon in space and are a dangerous but unavoidable part of living in orbit. Dust, rocky bits traveling across the solar system, and even man-made space debris routinely intersects or orbits the Earth, and sometimes a human spacecraft is in the way. In 2012, a micrometeorite impacted one of the cupola windows of the ISS, leaving a sizable gouge in the module's thick protective window panes. The shutter, which helps protect the module's windows in an emergency, were temporarily raised, and NASA evaluated the risk and the impact posed. The space shuttle itself was a victim of micrometeorites on several occasions, and once impacted one of the forward-facing windows, causing NASA officials to be concerned that the window may develop a large crack during re-entry and limit the pilot's visibility. Today, the threat man-made micrometeorites pose to spaceflight is growing, and NASA has held many competitions for the public to present their solutions for space junk cleanup. If left out of control, the buildup of space junk could eventually lead to a condition known as Kessler syndrome, a state where so much orbital junk crowds the Earth that reaching orbit is far too dangerous or impossible to attempt. In that case, humanity would be stuck on the ground for decades, possibly even centuries, as gravity and friction with atmospheric molecules slowly decayed each piece of space junk's orbit. Yet, as the micrometeorite explanation was examined, it didn't seem to fit the bill. Carefully observation or photographs of the puncture clearly showed that the penetration of the hole came from within, not the outside, making a micrometeorite impact impossible. On even closer examination, the hole actually looked like it had been drilled mechanically, and very purposefully to puncture through several inches of protective inner and outer shell. Additionally, what appeared to be scratches made from a drill are apparent alongside the hole, as if whoever drilled the hole was faltering in their attempts to actually drill it. This raised serious red flags across the international space community, and especially within Roscosmos. Theories were immediately raised, and one leading theory was of a mistake by the manufacturer. Yet, as many pointed out, the hole was so deliberate and completely punctured the thick hull that a simple mistake seems improbable. Whoever drilled this hole did so with intent, and perhaps it could still have been a mistake. Perhaps an engineer misread a blueprint and drilled the hole believing it would serve a later purpose. If so, then it brings into serious question the expertise of Russia's rocket manufacturers, along with a whole host of red flags on the incompetence of both Russia's manufacturers and its safety and quality control systems. Even more troubling, though, is the theory that the hole was an act of deliberate sabotage. Someone somewhere had purposefully drilled that hole. All agencies involved considered the possibility that sabotage had occurred either in space or on the ground, and Russia's Roscosmos, a traditionally paranoid agency concerning sabotage, feared the worst. In time, the possibility that the hole was drilled in space was ruled out, and questions began to turn toward the time the capsule spent on the surface. The capsule had passed pre-flight pressurization tests, meaning that the hole must have been filled in with glue, which upon reaching orbit had dried out in the vacuum of space and then been sucked out, resulting in the ensuing air leak. But is sabotage very likely? Well, the obvious sign of a faltering hand behind whoever wielded the drill that caused the hole, evidenced by the scour marks on the capsule wall next to the hole, could possibly point to a saboteur who nervously and quickly created the hole while under pressure. This likely means that the saboteur would not have been involved in the manufacturing process and likely carried out the deed either before or right after the vehicle was delivered to Roscosmos. Yet, if this was an act of sabotage, then why was the hole so small? With such a small diameter leak, it would have taken the ISS 18 days to vent out all of its air, and as we saw, it was detected long before that happened. Whoever caused the hole must have known it would never succeed in killing the crew of either the ISS or the Soyuz itself, if that was the goal. Perhaps, though, the goal was not to harm the crew, but rather to do what it did succeed in doing: make the Russian space agency Roscosmos look very bad and embarrass it internationally. Since the incident a year ago, the ESA and NASA have expressed extreme reservations about continuing to use the Soyuz capsule, and the ESA is very much looking forward to America's commercial space delivery platforms to officially come online. For its part, Roscosmos has intimately investigated the matter, and in a press conference publicly announced that they discovered the cause and the individual who created the hole. Mysteriously and very frustratingly for American and European space professionals, though, the Russians are refusing to come forward with any details. In fact, the head of Roscosmos stated that he would not be making any information available as to the motivation behind the drilling of the hole on the Soyuz. Some have pointed to the possible sabotage by an American agent. After all, Americans have long complained of having to rely on another nation to get their astronauts into orbit and back again. If the Soyuz suddenly seemed unsafe to fly, or if there were fears of Russian saboteurs, then the American government would be pressured into finding a solution to the current lack of an American space delivery vehicle. If this were true, then it's happening far too late, with participants in NASA's Commercial Crew Launch program all coming online soon with their own orbital crew delivery vehicles. Boeing's Starliner is expected to conduct an automated test of its capsule soon, and SpaceX successfully ran a fully automated delivery to the ISS this past summer. In the end, we may never know what caused the hole in the Soyuz capsule, and it's unlikely that Roscosmos or the Russian government will ever tell us. All this secrecy hints at something devastatingly embarrassing for the Russian space agency. But is it more than just an incompetent manufacturer? Could the real problem be something as terrifying as purposeful sabotage, with the only space program in the world which can currently get astronauts safely up to and back from orbit? Could human lives be even right now at risk? Given Russian secrecy, we may never know, though we hope that at least they have taken steps to address this very critical issue. What do you think really caused the hole on the Soyuz? Why won't Russia tell the world? Would you feel safe with your country's astronauts flying aboard the Soyuz today? Let us know in the comments, and as always, if you enjoyed this video, don't forget to like, share, and subscribe for more great content.